Hey guys, how's it going? I think you can see me now, right? Hopefully. Let's turn that off real quickly and we're gonna get into it. So, real quick question. Can you guys hear me before I switch? So like, I have a screen like this. We're going Inception mode where basically I have something on the left and the right. And so I typically switch it before I start the stream, like right before. And I don't know if you can hear my microphone from that, but yeah. Anyways, that's an aside. Just curious. Let's see if I can turn on my cursor highlighter very quickly. And nope, not that. Let's go here. I was sick this week too, so if I sound sniffly and stuff, I apologize for that, but hopefully it won't be distracting. Okay. There we go. Cursor highlighter is on, and we can get started in just a minute. Good to see you all. CLO Mater X. I'm not sure if I'm saying that right. How's it going? Hilbert Curve, CGO Clan, Langors, good to see all of you. Don't recall hearing anything on second screen. Okay, good. That's what I'm hoping. I try not to make any noise anyways, just because I'm like, that'd be weird if you guys like heard me sniffling or sneezing or something right before the stream starts. I don't know. So, okay. So what are we going to be working on today? We're going to be working on the block editor again. But don't worry, I've made, I think, a lot of progress. And I want to work on the next phase, which is going to be serialization / deserialization, so that we can sort of move on with our lives and get this thing done. So, good day today. How's it going, Darklight here? And Sam, good to see everybody. So, I have the progress I've made. So basically, if we go here, and I play something. Hey, thanks for following, Sil Wallenish. I think I'm saying that right. Thank you for following. Good to see you. So if I go into here, I've basically changed a couple things. Right now, you'll see there's no place or delete. You can just hold control and then it switches to delete mode, which I feel like just makes a lot more sense. Another thing, if you can see in here, we have ambient occlusion, which is nice. So now you can actually see the blocks a little bit better as you're working with them. Just makes it a little bit easier to see like boundaries and stuff. I've also added this option over here, auto rotate sun, and you'll notice it kind of flickers as I'm going and turning around, and that's because it's like switching the sun to a position that will give me hopefully the best viewing angle. If I turn this off, well, this isn't a good example because that is where it is by default. So if I go over here and then I turn it off, you'll notice it kind of just swaps the directions and you can't really see this boundary over here. And so it does help out. Like, I guess I can't see this boundary now, but you know, it helps a little bit, which is nice. Also, you can toggle on and off sunlight. So if I turn sunlight on, this is purely ambient occlusion, which you can tell you kind of lose that shaded look up here. So sunlight off, ambient occlusion you can turn off. It looks kind of weird. If I turn off auto rotate sun, you can see it's a little bit better there, but it just gets a little bit darker because of the way I have sunlight working. It's just not the best. So typically leave both on, which is good. You can turn both off if you want just a flat look. So you can literally just see the colors, which is helpful if you are painting. And let's turn it up. Look at that. So now I can go ahead and paint entire faces. I have my brush size up to 16, and it will basically just paint all the stuff that it can on that face. And then we'll change it to like blue or something. And yeah, you'll notice like down here, it painted, let's go down a little bit. It goes through blocks, right? Because like basically it's finding the 16 faces that it can actually paint on this side. So it's going there. If I turn this down to 1, then I can paint like individual faces and stuff if I wanted to. But yeah, so that was an improvement I know we had talked about and which was definitely needed. But that's pretty cool. And then now we can go back to block mode, and you can see if I turn off sunlight and ambient occlusion, we just get the colors, which is not very helpful, I think. I think at least ambient occlusion should be on so that you can still kind of see boundaries and stuff. But I don't know. You might want that for whatever reason. Miri4F, how's it going? And Langors, maybe adding wire mode would help. That's something I've been thinking about too, and I think we will add that eventually. Not strictly necessary right now, but it's definitely something I think I'm going to add eventually. Here, I'm going to take some coffee real quick. You'll also notice, or maybe not notice, FPS is much better. I have a couple tool tips here too, just so that you can see, like, this is the instantaneous FPS, which is why I called it IFPS. So extrapolated, this is the actual FPS. So this is like how many frames actually occurred in the last second. So good to have tool tips, I guess. But you'll notice it's a lot more performant, and it's probably smoother, hopefully, for you guys. And that is because I have implemented face culling. So if I go into here, you can see there's no interior faces, which is good, because that means that basically I've just done the same like chunk culling faces things that we do in the main game. And that's also how I'm doing this ambient occlusion. And it was definitely necessary because when we go to export, we will only want to export these vertices, which are the vertices on the surrounding edge. So I kind of think that's a good thing. Yeah. Miri4F, for the sunlight, you can do Fresnel equation, the fragment shader. That way the sun will always face you. Well, see, I want to do the opposite of that. So what I'm doing right now is I just have a few predefined positions, like the sun can be in the corners. And I have a few specific corners that I've chosen. And I just do like a dot product with my forward vector with the way the sun is positioned. And I basically just check to see which one is closest. Because I want the sun to be facing towards where I'm looking for, not towards me, if that makes sense. Like, because if it's towards me, then I'm going to get the backlight, but I want it to be lighting from the direction I'm facing. But might be worth looking at in some time. So yeah, this is basically where we're at now. First thing we're going to do real quick is get this create face thing done, which is we need a way to like add faces so that we can add these colors to specific textures. And the reason for that is if we go and do like, let's see, let's turn this up and then I'll just delete all that. Okay. So if we have something like this, right? And then let's say I dig like a hole in the center of this. Let's see if I can get this actually centered. That's not centered. Let's go up to 10. Yeah, that looks centered. Okay, so we'll go down. I totally messed that up somehow. I need undo. That's another thing that I need. Okay, let's see. There we go. So if we go down like that, we kind of get this tunnel thing. And we still need like a block flood fill type thing, all that stuff, which we will eventually get to. But yeah, so imagine we have a block like this, and you might be like, well, what block is shaped like this? And my answer to that is in Minecraft, we have things like cauldrons. So we'll clean this up a little bit, and then I'll continue on with my rambling. See, I definitely need some sort of tool to help in like cases like this, because this is just annoying. It's like you want to just fill that area. And so we'll have to come up with a couple of flood fills where it's like flood fill, you know, there's gonna have to be a couple different kinds, but it shouldn't be too bad to implement. Okay, so we got that. And then let's go ahead and fill in the bottom here. Let's actually just do, I think it was 10. Yeah, we'll do that. And then we will go ahead and try and clean this out again, and hopefully that'll just go down. Cool. Okay. So something like this. I promise I'm almost there. All this work is going to be wasted too because I can't save it right now. So that's something else that we definitely need to get working. Every time I do something like this, I'm like, should I really be working on this since I can't actually save it? Okay. Good enough. So we basically have a block like this, right? Where it's like shaped, kind of got this cylinder face. And the problem is, how do we apply textures to this? Because eventually what we're going to have to do is we're going to have to like say, you know, textures. Well, one thing you could do, which you might be thinking, is like, oh, this is one texture, this side of the block, right? And yeah, that is one texture, but do you want to use a separate texture inside here? Like, do we want to allow people to do like one color in here, different color in here? I'll have to fix that Z fighting too. I would argue, yes, I think this is probably something I would want to support, different colors for different faces. And so what that means is, well, all of a sudden we have one texture for this face and we have one texture for this face. And so I need some way so that when I finally create the output format for this block to be like, okay, the textures will get applied in certain directions. King Theos, thank you for following. And so I need to be able to say to the user, hey, select which quads are part of specific faces. So then they can select all the quads here and they'll say that's one face. And then they can select all the quads here and say that's one face, and so on through all the faces. And so basically that's what we're going to be doing. And it looks like we got a spammer. But yeah, so that's the reason we have to sort of get this face thing done. And then once we get that done, we can export and import, since we can finally create the textures and stuff. And thank you, Langors, that was quick. So we can finally create the textures and stuff and then import those as well. So that's the plan. We'll get that done, and then we will get exporting, importing done. And Bram W0, thank you for following. Also, Charlie Pyre, that is a chunky cauldron. It is very nice. I appreciate it. And CGO Clan, add support for FBX, that should help. FBX isn't good in this case because we don't want to do like generic 3D models. This is a very specific format because I want to import it directly into the game. You'll be able to make blocks in Blender. I tried that. This is the problem you run into. How do you apply textures? And there's a very specific format for the game. If I create this, it is going to be a lot easier to control exactly what types of blocks they can make. That's the whole reason that I'm creating this block builder thing and not using Blender, is because Blender is too much variability. This is very constrained, and I can create a binary format specifically for the GPU using this. So that's the reason that I've kind of done this on my own and not used Blender, which I did start with in last 2 streams or something. Okay, so actually, let's open that back up real quick. How are we going to do the create faces thing? Well, I have this block painter mode, and this is where we're going to be able to create faces. So I think I'm going to use sort of the same. If we go to this, like I do that, create face. I think I'm going to use the same thing that I'm doing here, right? Because this is almost exactly what we want, right? We want to be able to just say, hey, this is like one face. And then we also want to add in, like, they can shift click or control click to add, like, then if they go down to 1, they can like shift click to add specific and then control to deselect specific faces. So that is basically, we can steal most of that and then kind of go from there. CGO Clan, you would be able to make, wait, is a crumble so advanced it needs a custom block builder? I don't think it's that it's so advanced. It's just that it's easier. If we look here, let's go. We're going to pull up OneNote real quick. I'll just drag it over here. This is the binary format on the GPU right now. We have these things. The problem with just using Blender is we have to store those vertices inside a texture. And the problem with that is I have this vertex offset index here. And you'll notice this is only 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 bits. And if we do 2 to the power of 12, that means we can only have 4,096 unique vertices, which means that we can only have 4,096 unique vertices for all the block types. I feel like that limit can be approached pretty quickly. Whereas if I have this block builder, which is, do I have it running? No, I do not. Okay, if I have this block builder, we have 16 by 16 by 16 cubes. 16 by 16 by 16 cubes, if we look at that, takes, okay, if I can do math, 16 by 16 by 16. 4,096, same amount of bits, right? Except for each cube, we have the potential for 8 different vertices. So we have to multiply this by 8. This is going to be a high end because we're double counting some stuff, but that's fine. So 32,768. If we take the square root of this, no, if we take the logarithm, I think of this, natural log or logarithm? I think if we do log, no, natural log. Just want to do natural log, no. Okay, anyways, 32,768. What is that? That's like 2 to the power of 16, I think. Right? 2 power of 16. Nope. 2 to the power of 14? 15. Okay, I think that's 15 bits. Okay, that's 15 bits. So this means that we need 15 total bits. Well, we have some extra bits down here. But what this also means is we can store infinite amount of blocks because now we can store the position directly. And also, hey, Sockham, thank you for following. I don't want to leave that out. But this means we can store an infinite amount of block types because instead of storing like stuff in a texture and then looking it up, we're literally storing the position. It's going to be encoded in 15 bits, and then we're going to have to decode that to an actual position. But we're going to have that information directly available, which means we can store infinite amount of block types. So it's kind of weird. It's sort of the same thing I'm doing here, where we have 4 bits for the X, Y, Z position inside the chunk. And that means we have 4, 8, 12 bits. It's kind of weird. But it basically means that we have a lot more possibility with this and no limit. Let me just catch up on chat real quick. Will the format have AO baked in? It will. That's another reason that I'm doing it this way, little guy, is because we can bake in the AO ambient occlusion, and that's a lot harder to do with a blender. CGO Clan, wait, Gabe, has Steam, what games you play? Recommend Elden Ring, definitely worth it. I play lots of different games, but we can talk about it another time. So, hey, Sockham. So glad to find you on Twitch. Your Minecraft tutorials being crazy helpful for learning OpenGL. Thank you so much. Yeah, no problem. I'm glad that you're finding it enjoyable. That's why I kind of hesitated to call it coding Minecraft, because the first part of it is definitely geared towards like OpenGL concepts. But Minecraft is cool and it's clickbaity. So, you know, it gets more people to click on it. CGO Clan, you use 6 bits for skylight level. Yep. A 1 to 31. 2 to the power 6 is 32. So yeah, 0 to 31, I guess. You're a stellar teacher, so clickbait all you want. Thanks, I appreciate that. Hopefully it's not too clickbaity. I try to be like pretty transparent, but Minecraft does get more people drawn to it. So, okay. So create faces. That's what we're doing right now. Let's go ahead. We want to, first of all, I think we need to add a brush size. And I'm going to show you guys something else too that we're going to have to fix because it's very annoying. So if we do, yeah, let's do place block 16, create face. Okay, so we've got the brush size there, which is good. We just want to add an actual like interface. It's not doing anything when we do that. So what we can do is, I think I have something in here called handle create face. Yes, I do. And if we go down here, this is it. And I think this, which is what we can just grab, is the handle paint block. Okay, cool, which it is. So we can just grab that and copy paste. This is going to be the quick and dirty method. And what do we want to do? Yeah, we're going to have to, this is going to have to be a little bit different. So this is if they actually click the mouse left. We're going to have to do some different stuff here than what I'm currently doing. So let's actually just comment this stuff out because I don't think it's going to be the same. It's going to be kind of similar, but different. So basically, what do we do? I guess I should explain this a little bit. This is for when the users like clicked create face, they have the editor open. They're kind of doing this editing job. So what I do is I shoot a raycast from the, that's not what I wanted. I shoot a raycast from the camera's view. So what we do is we get the mouse to ray, which is basically just like where the mouse is on the window into a direction into the world. Then we raycast from that direction. So we use the ray direction from the position of the camera, which I guess isn't technically accurate, but it's close enough that it doesn't matter. And I go 50 units and I don't want to draw anything, which is just that last thing. I think it's defaults to false, but it's all good. We get that raycast result. If we actually hit a block, then we want to draw the highlighted form of those faces. So what I do is I get this min max bounds things, which just sort of gets the brush size and figures out how far we need to go in both directions for the brush size. I guess we'll comment this stuff out too for now. This compile geometry is basically just something to recompile. It basically just remeshes the chunk. So I guess that could be called mesh geometry as well, and it's the same thing. Next, I figure out which direction we're iterating in, because if you think about it, if we look, I would compile, but I don't want to do that. If you think about a cube and you're looking at faces, you have 6 different faces, right? 6 different normal directions. You have north, east, west, south, and then you have like, those are the cardinal directions, right? And then you have up, down, back, front, which are like kind of those other cardinal directions. So what we do is we figure out which 2 axes we're operating on, because a unit normal is going to have one, like if we bounce off the ray, we're going to have one direction, the X, Y, or Z, that's not 0. And we want to iterate across the non-zero components. Hopefully this makes somewhat sense. So basically I'm figuring out which components we want to iterate over, and I have this funky for loop, which could be done much better. But basically I just make it so that we're only iterating once over the path that we don't want to iterate. It's kind of weird. I don't know, but it works. Okay, so then we get the block centers of each thing we're doing. We basically determine if the face is visible. If the face is visible, we draw it with the draw color, which we're going to change to, instead of this, it's going to be GLM vec4, and let's just go HTML color picker. And we'll choose yellow highlight color. That's good for me, and we'll just copy that. And we'll do that, and we'll do like 0.8F, so it's semi-transparent, and we have to normalize these values because, yeah, that's the way colors are accepted. Actually, why am I doing this? I have something better. We could just do this. I forgot completely about this. And then we could do that hex. I made this utility thing, which is so much nicer. Okay, and then I want to turn down the opacity, so we'll do like EE. Now we'll do like CC. Okay, so that should give us like a semi-transparent color, and this will basically just convert it. You can see this just calls a function that converts the hex code to an actual vec4. So that's all that's doing. And we'll call this highlight color. And then we will just go, and I don't know if you noticed that, but saving takes a long time and compiling takes a long time. So I'm going to hit compile. We're going to sit here and wait for a second, and I'm going to talk about why it's taking a long time, and we're going to try and fix that. I am Citron. Thank you for following. Still compiling. Yep, very fun. So why is it taking so long? I didn't make many changes. I just changed one file, and we'll talk about that because it is kind of annoying. And although it's nice to have it, my code the way it is, since it's leading to this long compile time, I'm definitely going to change that. Okay, cool. So you can see this is working. I've got a yellow highlight color. Let's just make sure it's actually semi-transparent. So let's paint some red there. And if I do create face, we should see like that red peeking through a little bit. I might need to turn down that transparency a little bit more, which we can do. But yeah, this is that's working pretty good. If I click, it doesn't do anything because this is just gonna be like creating faces. So we're good there. Why does it take so long to compile? I'm not completely sure, but I'm 99% sure I know why. I think it's because of this and because of, let's see, there's a couple things. Somewhere, oh yeah, because of this, and there's one more somewhere, I think. No, just that one, yeah. Okay, just those two. So I think it's because of this and because of this. Why would that take so long? Well, let's take a look at the binary size, because I have a feeling this is exactly what's causing so much time. So if we look at Crumble Block Builder, okay, it's not that big. It's 2,637 kilobytes. Yeah, that's not that big. Weird. So why I think it's taking so long is I think since we're statically compiling this, what it has to do is it has to allocate memory for max num face verts, which you can see is 147,456 vertices, which is kind of a sizable chunk. And I don't know if it's the template that's like causing this to increase the compilation time, or if it's just the fact that it has to compile this into like the read-only memory or something. I'm not sure. I think it is one of those two, and like the fact that I have it 0 initialized. And so we can do a simple experiment to see if that is true by just changing that to that, that to that, And we can just go down here and say face vertices equals face vertex star G allocate memory, or G memory allocate size of face vertex times max number face verts. Okay, so that's that. And then we also need to free that memory, so we can just go down to free and we can say G memory free face verts, or face vertices. Okay, let's see if that speeds it up real quick. Hey Sock'em, if you lower that number, does it go down a lot? That's kind of what I'm checking. This is similar. It's a little bit grosser just because I can't like use dot size anymore, but I'm okay with that because we don't really need that. And then we can just change this. And it looks like I'm not using that dot size anywhere anyways. So if I allocate that memory dynamically at runtime, should speed up compilation is what I'm thinking. And it does. Okay, cool. So that is exactly what was making it so slow. So I guess word of advice, be careful how much memory you're statically allocating, because it does bump up compilation times. 99 is 100 now? Wait. Am I missing something? 99 is 100 now. You might have to expand on that a bit. Certainty. Oh, yeah. 99%, 100%. Yep. Okay, I got you. And it's still kind of slow too. And I think it's still kind of slow because we are also allocating static array here. 4096, which isn't that big, but it is kind of big. And yeah, I think I do want it. We'll switch this up too. Once again, not the most ideal, but it is definitely easier. And since I had those 0 initialized, let's also 0 that stuff out. So we can also do G memory 0 mem, which is part of a library that I've made just to make stuff like this easier. We'll do that size of face vertex times max number of face verts. And then we'll just do, I think that was cubes equals cube star G memory allocate size of cube times max number cubes. Max cubes. Or no, I don't even think I had that. I think it's just I did 16 times 16 times 16. Let's pull that out into a constant. Max number cubes. And then let's go find that and go back up where that's at. There we go. Okay. So we'll do that. Static const expert int max number cubes equals that. Okay. And then we can go back down to there and do this. Okay. So any reason not to use a stood vector with an initial capacity? Because I don't want it to grow. I just want to have like a fixed size, which is really annoying because I wish I could. I wish I could do like a dynamically allocated fixed size container, which unfortunately doesn't exist. It will allocate memory in the heap only and reference a couple more auxiliary variables. Yeah, exactly. And that's why I would, because I thought about that, but like, just because it has the ability to grow, I don't like that because it's not representing what I want to do. I do want like a fixed size container. And there's just, not that I know of. If there is a data structure, that'd probably be the one I want to use. So, okay, so we do that. And then we'll say G memory. The garden girl, thank you for following. 0 mem. We will say cubes, size of cube times max number of cubes. There we go. You can also use an array allocated on the heap. Can you allocate an array on the heap? Sam, you would use stood vector with initial capacity. Yeah, because with a vector, what I'm signaling to myself is this might grow, but this won't grow. I know this is the maximum capacity that I need, and so I want to keep it that way. So that's like, I don't know. There's semantics with all these data structures and stuff. And this is a lesson I learned when I worked at Amazon and interned there. I remember I was using a sorted hash map, and the senior engineer or whatever, he came up to me and he's like, "Hey, why are you using this? What does this do?" It was called something weird. It wasn't called sorted hash map. It was called something else, but that's essentially what it was. And I told him, and he was like, "Why not just use a list?" And I was like, or like an array list. This was Java. And I was like, "Yeah, I guess." He's like, "It's important to make sure that your data structures are mimicking what your intents are, and that they're matching what you want to do. If what you want is a sorted list, use a list. Don't use a sorted hash map, because that's what makes the most sense." And I don't know. So kind of like that whole thing. Belangor's int star a equals new int size. Yeah, that's essentially what I'm doing here. Same thing. I'm just doing it with, if I use my library here, I can track this memory. So I like doing it this way because, like, for instance, I've allocated this memory, but if we compile and I close the game, since I haven't freed it, it's going to warn me. So if we do that, memory leak detected, allocated on line 170 of playercontroller.cpp. So we can kind of see that there. And if we look, this is line 170 of playercontroller.cpp. So I like using my library when I can, just because then I know exactly if I'm forgetting something on accident. Yeah. Cubes. So that's that. And notice how much faster that compilation is now. So much better. Look at that. Instant. Okay. So that's something. It was really bothering me last night. I thought it was Visual Studio at first. I was like, what the heck, Visual Studio? Why are you going slow on me now? But no, it was my code that was statically allocating a lot of memory. Okay, let's see. So we got this. We've got this create face thing, which currently doesn't do anything. So the next part that we kind of need is we have this create face settings. We want a way to like see which faces have been created, figure out which one we're on, and then like add to it and remove from it, if that kind of makes sense. So that's kind of the next thing. Or you could just allocate the stood array itself. Yeah, I don't know. I mean, it's all the same at this point, you know? It will move it to the heap. I don't know if you can. I mean, you can declare like an allocator for a stood array. I think if we do stood array, we got type name and size. I don't know if they allow you to add your own allocator for that. I don't know, but pointer to pointer. Thank you for following, and good name. I like that. Pointer to pointer. Are you a linked list? Is that what I'm seeing? Okay. So I'm fine with this solution. There's nothing wrong with using raw pointer or dynamic memory. I think, you know, we just checked. There is no memory leaks. I am clearing the memory. It's not like it's a big deal. I guess you could have out of bounds errors and stuff, but you can just throw a few assertions and everything. And I do have those scattered throughout the code. So it's all good. I also have too, so another reason I like this too is if we were to, what is the max size? Our max size is max num cubes. Well, what happens if I do max num cubes plus 1 equals something? This is a classic error, right? And this means that now we have gone overrun. This is a undefined behavior, dangerous, bad. So what happens now? Well, let's do this. If I close, look at that. Heap corruption detected. Buffer overrun in memory allocated from line 170. And so I also have this built in where it can detect the heap corruption, and I'll zoom that in a little bit, and it tells me where the memory was allocated from. It can't tell when it was corrupted. All it can tell me is that it was corrupted. And this isn't foolproof. There are ways that you can avoid this, but for the most part, it's going to catch most heap corruption. So another reason I like using my library a little bit better, when you free that memory, it's going to detect if you have corrupted the heap by doing an underrun or an overrun, and it'll tell you which it was. So kind of narrows it down a little bit. Like if I had also done cubes like -1, which I think you can do, negative pointer arithmetic, it should tell me like heap underrun. So if we do that, yeah, buffer underrun. So it's telling me I've gone before the bounds of that memory. So it's pretty nice, you know, and it's not too hard to do. It's a good project if you ever want to try it out. Thanks, DV222. That is really cool. I appreciate it. I think it's cool too, but I don't know if it's completely necessary. I don't know, but Langor is even better. Wrap it in a unique pointer. Yep. See, that's what C++ people say, but unique pointer doesn't give me this stuff. So can't detect heap corruption or, I guess it does the memory tracking automatically, but then you can't control when it gets freed and stuff too, which I don't like. So, hey Sock'em, he's a linked list of personality attributes. Nice. Okay, so that aside, we want a way to add different faces. So in our create face GUI, what we're going to have is basically like, we need a data structure. A data structure that keeps track of a face. And what does that data structure look like? Well, let's go into here, player controller.h, because I think this is probably going to be the best place to put it. There we go. Langors, you can give it an allocator, I think. Yeah, I know, but it's like, I don't know. It's not a big deal to me. I don't like unique pointers and shared pointers and all that stuff because I feel like it's doing the one thing that you should be thinking about. Like, you give it, this is a problem I ran into too, because I started using shared pointers and unique pointers and all that stuff. And the problem with that was like, this is the wrong player controller too. The problem with that was I stopped thinking about memory. And when I stopped thinking about memory, I ended up having all these subtle bugs where it was like, where are these coming from? And then when I switched to manual memory management, my performance increased because I was thinking about what I was doing and I had complete control. I don't know. Yeah. Better thing is just to use what you're comfortable with. Yeah, I agree. It's just, I don't see any problem. I think there's a big stigma in the C++ world against doing manual memory management for a reason, but there are plenty of tools that you can use or create that definitely alleviate a lot of the problems. And there shouldn't be as big as a stigma, especially if you're using C++. Like that's the reason that most people use it is to get that control. And it's okay to use shared pointers and stuff. And I will use that stuff where applicable, where it makes sense. But yeah, let's do a struct. We need a struct, which is going to be like some sort of face data. Face data. So what do we need in the face data? We need like a normal. So this normal kind of tells us what direction we can take. I guess we technically could take like different directions and have those all be part of one face, but I like the idea of keeping it all same normal. Yeah, if we keep it all the same normal, that should give us some ability to like do other calculations a little bit easier. So we're going to keep it faces, same normal. They all point the same direction. So that's the first thing. Next thing, what else do we need? We need like the cube positions. Right? So if we have the cube centers, that should be all we need, right? Because we have the cube center, we have the normal, then we can calculate the 4 vertices that correspond with this face. Mars Chi, thank you for following. I hope I said that right. Chi and not, I think that's how you do Xi. I'm not sure. So yeah, cube center plus a normal gives us 4 vertices for that face. And we have several of these. We can have up to 16 by 16. Because we're only going to allow 16 by 16 textures. And I did that wrong. That's Java style. Which makes more sense in my opinion. But 16 by 16. So that's the max number of cube centers we can have. Because that's the max number of faces we can have per thing. Should we? Yeah, this is okay. Yeah, because this is one face max number, and then we can have like a int number cube centers. So normal cube centers, and then we need colors for each of those cube centers. Now the colors we're going to embed into a texture once we export, but that's further down the line. So we will have face colors. And this will be a vec4, also 16 by 16. And then number face colors, which should be the same as this because we want to keep these kind of in line. So let's actually face color. Actually, yeah, let's do this. Let's do this is face data, and then we'll have a struct face. And face data will have a cube center and a color. So we'll do like cube center, color, and then we can abstract that stuff. So then we'll say we have a vec3 normal for a face, and we have face data, faces, I guess we could call that. And this is 16 by 16. And then we can get rid of all this stuff, and we can just have number faces. Okay, and I'm gonna change this to a pointer because I don't want the same problem we just had. So don't worry, that's gonna be, yeah. 16 by 16 is the number of pixels for textures? Exactly, yeah. Why so small? Doesn't Minecraft support 256 or higher? I think it does, probably. And I'm kind of debating, you know, I might support something like that in the future. So the reason I'm doing 16 by 16 right now is because if we go into here, let's see, what's wrong with this? We need to include core.h. Okay, let's do that. Okay, so the reason I'm keeping it 16 by 16 right now is just because of the way this works, right? The most granular we can get is 1. And my brothers who are doing the artwork have said to me that we started off with 32 by 32 size textures, and they said that's too many pixels. They were like, we don't really like, you know, the size of that because it's just like a lot of work for one block. So we're going to keep it pretty low res, just do 16 by 16. And this kind of keeps to like a more voxel kind of look. I don't really want it to have like a textured look. I'm definitely going more for like, what is it? Valorant. Somebody in my Discord showed me this a while ago, and that is what it's called, right? Valorant. Okay. Valorant. Yeah. And I think, so like you can kind of see these are definitely more voxely kind of looks, and I do like that a lot. So definitely going for more of kind of this look, which you can see the textures are a lot bigger, which makes sense because we're doing like making it look like it's individual cubes, but we're kind of alleviating some of that pressure using textures to expedite some of that stuff. So 16 by 16 for now. 32 definitely high detail for pixel art. Agreed. Yeah. And why not make the number a defined macro in case you need to change it? The reason I'm not going to make it a macro in case I need to change it is because like to change it would require a lot of work anyways. So keep it this way for now. And then in the future, if we decide to expand, we can, and it'll have to change a lot of stuff. Yeah. So going by feel here, we'll see how it feels. And then if we need to change it, we can change it. So we're going to do this. Let's do like a, something like that. And then we can just do that. And we're going to do the same thing here, just so that we don't increase compile times unnecessarily. Yeah, I think I'm okay with that. Okay. So we got face data, which consists of a color and the center. We have the normal embedded in the face itself, and then we have the faces, and we have the number of faces. That should give us everything we need to calculate. Yeah. I'm trying to think if this is like how I want to do this, because the reason I'm kind of tossing this up in my head is because if we look up here, what I have is this cached vertex thing, which consists of position, color, face normal, ambient occlusion. This is the stuff I kind of want to... Yeah, okay. I think let's do this instead. We're going to have a face index. I like this a lot better. So each vertex is just going to keep track of which face it's a part of. And then when we add a, yeah, I think I like this a lot more. But then let's see. Cubes. Okay, then we might need to add it to this too. Ooh. Yeah, I think this is probably going to be the easiest way to do this. Okay, whatever. So then a cube is also going to have like a left face index. Right face index. I'll do it in pairs. Front face index, back face index, top face index, bottom face index, which this is getting pretty chunky, but I don't care too much because this is just the editor. We're going to compress everything when we export. So the reason we have to do it this way is because we need the cubes to kind of persist the state that's embedded in these vertices, because these vertices get generated based on what these cubes contain. So if we have all this stuff, then we can sort of embed that information as we go through. So we've got the face index embedded in there. That means we can't do this, which means also that we should probably take this out of here, maybe. Take that out of here. Put it in here. No. And the reason I'm tossing this up now is because we basically need a way to get this information to our panel, which contains like, so that we can actually like figure out which faces are part of which index. Actually, no, we don't. We don't need to do that. Okay. Let's do that. Leave it in here. Okay. So then the main panel, what's the main panel going to look like? Okay. I think I got this. So create face GUI. We're going to have the brush size, and then we're going to have like a button, which is a plus, which is going to say like I am GUI, add, or let's do button for now. We'll make these better eventually. Add face, new face. Okay, so this will add it to our face index array or whatever, right? What do we give it? Just a size. We'll let that be whatever the size is. Let's go up here now, and what we're going to have is just like a static int somewhere up here, number faces, which is 0. So then we'll have that. So if we go back down, where was that? That was right up here somewhere. Create face GUI. Okay, here we go. So if this is clicked, then we'll say that plus plus, right? And then what we will do is we need a way to, like, if you remove a face, you want to remove that. Maybe we'll do that a little bit later. For now, just do the simplest thing. Jomega, good to see you. And that's pretty cool. Working on Vulkan extension. Nice. Okay, so we'll do this, and you need a way to select which face you're currently working on. So what we'll do is we'll say for int I equals 0 until I is less than number of faces, I plus plus. And then this is, so okay, this is how we'll sort of link everything together. What we'll have is we'll have like a static int face that we're working on, which is gonna be like -1, right? Yes, okay. So we've got that. We'll go through here. We'll say if I am GUI radio button, I guess, face, and let's just do stood string. See, I'm not against C++ construct completely. This is nice. We'll say stood string label equals face plus stood to string I. Okay, so we'll have face that label dot C string. And we want to do active is going to be I equals face working on. Okay. So if we click that, then we're going to say face working on equals I. Sweet. So now we can like switch between different faces that we're currently working on. And then what we need is we need a way to get that information out of here. So we'll say bool is working. Well, actually, we'll just have like int get face working on, I guess we'll call it. So we'll do that, save. Let's go below auto rotate sun, which is up here somewhere. Okay, so we'll do that. And then we'll return face working on. I think that's what I called it. Yep, okay, cool. So we got all that. Now we should be able to add and then select which one. We might want like a drop down or something, which will be a little bit better, which I can change in the future. That's just, can we change stuff? Yeah, okay, so we loop through, we check whichever one's active. Okay. I think that's good. So we do that. Now if we go back into the player controller, we can get that information. First of all, let's just make sure it looks correct. Okay. Is Asher in the community still working on the 2D game? Don't remember what it was called. Azurite. Yes, I think it was called, it is called Azurite. I believe they are. I think it might be on a little bit of a hiatus, but because of finals and stuff for a lot of them, but do believe it's still being worked on. Sorry. Okay. By the way, good to see you, Essie Woods. Okay. So let's go. We're going to place block. Okay. So if we go to create face, we can hit add new face. Cool. And then you can see that we've got like, it just checks these things. Cool. And then we can just click between them, which is good. If we go to paint face, we probably want to reset that. So if we toggle off of that, we want to just get off of it. So let's go back into here. Basically, if, okay. Yeah, okay, so if we switch here, what we're going to do is we're going to say face working on equals -1. Okay, so that should like switch it off when we turn off of that. So let's see if we go back into here again. And we go here. So if I go that, I click here, we're on face 1. If I go here and then go back, we're off of it. So there's none selected. Cool, so that's what I wanted. Cool. So we can now add faces. We'll probably want like an X here so we can delete them too. Eventually, that's going to be a little bit more complicated maybe, but we'll see. So anyways, we've got this method though. Now we want to go and use that information inside the player controller. Now I know this was supposed to be about exporting binary formats and stuff, but we will get to that. I promise. This is like, we have to prep for a little bit using this. Langors, is that addressed to me? I think that might be addressed to Jomega, maybe. But if it is addressed to me, I don't know. Converting quaternion to Euler angles or Euler angles to quaternions would be enough. I would probably do both of them, just because like you may want to display stuff and everything. Whoa, Essie Woods gifting tier 1 subs. Thank you. That's epic. Okay, cool. Thanks, Essie Woods. I'm not doing a stream like my brother where we're doing adding time to the stream for every sub. He's crazy. He's doing like a 24-hour stream right now. So, yeah. So let's go ahead and start adding this stuff, though. Okay, so if we go process input for an edit mode none. Okay. So handle create face. This is what we want to go down to. Okay. So we want to basically say const, well, that doesn't matter too much. So we'll say int current face index equals main panel get face working on. Okay, so we get that. What we want to do first is we want to draw all the planes of the faces that have been selected already. So we can say for auto cube, and cubes, we can't do that because this is, yeah. So actually what we have to do is int I equals 0 until I is less than max number of cubes, I plus plus, and then we'll say cube, we'll do const cube ref cube equals cubes I. If cube dot occupied and cube dot face index. Ooh, okay, so this is, yeah, so this is where it's a little bit annoying. I'm trying to think. So basically, we have like cube back face index. We like, right, we have all these stuff. And we want to check and see which ones were so basically, okay, what we have is we can say if that equals current face index, right? And then what we can do is we can say draw cube or draw face. And then what we can do is we can give it the block center, which is cube center, cube dot position. And then we can give it the normal, which in this case would be, since it's the bottom face, we would do vec3 0 minus 1 0. And then a color, which is like our highlight color, right? That's all well and good, except we want to constrain the faces to be only one side. Excuse me, sorry. Okay. I'm kind of losing my voice here a little bit. Okay, here we go. So we want to constrain the faces all to be one side. So I guess what we should do is we should say like face index. We kind of want two things here. So let's do this. We are going to have struct face data, but all this is going to be is it could be an index and a vec3, which is the normal. Okay, so this is what we'll do to constrain them to certain sides, right? We can only have them pointing in one direction, and then this will just return face data. I guess we could do a ref. It doesn't matter too much. It's small. Okay, so we'll do that, right? Then inside of main panel.cpp, what we can do is have that return that, and this will now be face data, which will initialize to -1, and let's see, how do we represent a normal that does not exist yet? I mean, easiest way is just to say like normal exists or something like that. Yeah, I'll do this for now. It's probably better. I should definitely be doing something like enum class face normal uint8, because there's only so many. We only have like top, bottom, left, right, back, front, none. That's what I should be doing. And actually none should be the first one. And then like length. Yeah, we'll do this. This is better. I kind of like not screaming case too, so we'll switch this up. Left, right, back, front. Okay, so we'll do that instead. Face normal, face normal. I guess we'll just call it normal. Doesn't matter. So that's that. And then what we can do here is we can say, instead of doing this, face normal, none. Okay, that's better. I like that better. Cool. And if we go back to where we reset it, we can reset it here by saying -1, face normal, none. Okay, cool. So I like that much better. Now this, what we'll do is we'll say face working on dot index equals that, dot index. I guess I like reversing this. I don't like it when equality operators are like that. I is what we're comparing. We're comparing it to this. I like having it that order. Okay, so we got that. Now we have a way to kind of determine that stuff. So we can do that. Now if we go into player controller, we've got, this is now const face data ref. There we go. So now we can say if cube is occupied and yeah, okay, we can do this. We can say if cube is occupied and current face data. I'll just call that face data. Make it a little bit simpler. And face data dot normal equals face normal bottom and that. Okay, cool. So now we can say current face dot index. Or I guess, what do I call that? Face data dot index. Okay, so now this is good. We can correctly constrain stuff. Cool. So now we'll just do that a few times. Not ideal. I don't really care about this code too much. It's okay. So top +1, top face index. If I was being smart, I would like make all this stuff arrays and everything, but I'm not being smart and I don't care. So left is going to be left face index. That's going to be -1 in the Z. Then that's all good. Right is going to be right face index. That's going to be +1 in the Z. Okay, and then front, it's going to be front face index, and that is going to be +1 in the X. Let's be consistent here. Let's do bottom first, or I guess back first, and then front, since I'm doing negatives first for everything else. Okay, this will be back, and that will be back face index. Okay, -1 in the X. Cool, so -1, +1, -1, +1, -1, +1. We draw the face, all good. We are good here. Sweet. So this will draw the faces that are currently selected for whatever, this stuff. Now let's handle placing them. And then we can handle deselecting them too. So, yep. First time chat looks like it was scam. Hey, Sockham, Pascal case best for constant. Screaming is widespread but makes no sense. Exactly. I completely agree. I used to do screaming case all the time. And I was like, why am I screaming at myself? Like, no reason to scream. It's just a enumeration. Don't get why we hate enumeration so much. Maybe that's why people don't use them as often as they should. They're like, this thing's always screaming at me. Why am I using an enumeration? But we should. Okay, so we've got all this. Now, when we left click, what happens? When we left click, we want to basically embed these things as part of the cubes. The geometry is not actually going to change. No, it's not going to change. Because what's going to happen is we're literally just going to draw these on the fly every frame here, right? So if new things get added, they get drawn here now. So we don't need this actually change thing. That doesn't matter. We will need this thing. So we don't need this. Okay. So basically, what are we going to do? We are going to figure out which way we're iterating. First of all, what we want to do here too is we want to basically check if the face that we're currently working on. Yeah, okay. So first of all, what we want to do is we want to say like if face data dot index equals -1, right? So if it's -1 index, that means there is no faces. So we just want to return. Maybe we'll say like to do log warning to user or something, or visual cue that they are need to create a face first or add a face, right? That's not the best UI experience, I guess. UX, I don't know, user experience. But yeah, so we're just going to not do anything there. So if it's -1, we don't do anything. Now this ensures that we actually do have a face index. And then what we want to do is say, like, when we're highlighting stuff, we want to say if face data dot normal does not equal face normal, none. Okay. So if we've already chosen a face, we want basically check and see if the user's highlighting a face that's pointing in the same direction. If they are, we want to color it red. So we'll basically change that to red. That's good. Like that. And I think that's a CC hex. Once again, I was sick a few days ago, so if I sound weird, that is completely why. So I apologize for that. But yep. Kimi Chimaru, I think I said that right, is now following. Thank you. Good to see you. Okay, so if the face normal is not none, we basically want to see if face normal, we want to say if face data dot normal equals face normal back, or face data dot normal equals face normal front. Okay, right? So if we have a front or a back, that means we're in the X, and iter X is 0. Yes, okay. So if we, so what we're doing here is we're saying, okay, this says what? Why can't we assign here? That's a const glm vec4. Let's change that. This is not const. Okay. Why was I doing const reference there? Okay, that's not const reference. Okay, so if they are the back or the front, and the raycast, let's see, this is saying the raycast is 0. The raycast is 0, the normal of the hit. That means that they're not pointed to a, yeah, okay, I like this. So basically we're going to highlight red if they're on a face that's not pointing in the direction they need to be pointing in. That's all we're doing here. So then what we'll say is we'll say like face in right direction equals true, and if we hit one of these, equals false. And let's also just do like glm vec4 bad highlight color equals, and then we'll do this just so that we can change that in one place if we ever need to. And then we'll do this equals bad highlight color. Okay. Rithulkamesh, I think I said that right, hopefully. Thank you for following. Good to see you. So, could I see progress? Yes, we will see progress in just a second. So, I almost got this part done, and then we should be able to go and see progress. Okay, so if face data normal is back or front, and we're iterating X, that if very similar, if the face normal is top or bottom, and we're iterating Y, then we do that. If very similar, we could simplify this a little bit more, maybe we will. Left or right, and we're iterating Z, we want to say that. Yes. Okay. I guess what we could like abstract this more. It doesn't matter too much. Okay. So now we have like if it's in the right direction or not. And we should probably do this actually a little bit higher than where we're doing it currently. We want to do that up here because, yeah. So let's do this, and then we will abstract this stuff out of here because that's common. So do that, and then what we can do is we can remove this stuff. Okay, and now when they left click, I promise we're about to see it in just a second. All right, I too want to do this one day. It'll be nice if you can leave a guide on how you did it. I've got news for you. If you check out my YouTube channel, I have a very in-depth guide on how to do it. Why one day? Because I have an idiotic ARM-based computer, Apple M1, and I'm going back to x86 64 in a year or something. It's all good. Apple annoys me sometimes, but I don't currently own any Apple devices just because I don't like a lot of the things they stand for. But that's besides the point. I do have like an iPad, I think. So, yeah. They do have very good integration and stuff too. Yeah. Anyways, Frosty Toaster, me knowing nothing about what you're talking about. Yes, of course. Oh, Rithulkamesh, you subbed. Okay, cool. To the YouTube channel or this. Hopefully both. But no, okay, so let's go. We've almost got this. So if we left click and if it's the right face, so if we left click and, no, I'm not rich. Okay, it's all good. And this is face in the right direction. So if it's in the right direction, then we want to basically say if face data.normal equals face normal none. We basically want to set that then. So then what we can do is we can say void set face working on normal. And this will be face normal, normal. Do that. Go into here. We've got this. This is the closest thing to getter setters that I'll ever have to. So, okay. So face working on dot normal equals normal. Okay. So we do that. If this, yes. Okay. So then we'll say if iter x. Wait, no. If we want to actually compare the rate cast now. So we need something similar to this stuff, which is fine. Sorry for the sniffling. I will try not to do that because that's kind of gross. Okay, so if the hit normal is +1, we want to say main panel set face normal and face normal. This is +1x, which is front. Okay, so we'll do that. And then here we will do... This would be back. Okay. Otherwise, we do, this would be top. Okay. And then here, this is bottom. And then here, this is right. And this is left. Okay. So we've got all that. So if it was not, now we have a normal for this face. And then we can go through. Yeah, okay, then we can go through and we want to just set all these things now. So if the face is visible and the cube is occupied, and this was a right face, then we want to say cube's current block index, face, this is right face index equals current block index. Okay, cool. There we go. So this is what we can do now. So this would be left. No, that's front. Sorry. Front face index. +x. This is back face index. This would be top face index. Okay. This would be bottom face index. And this would be right, and this would be left. Okay, cool. So now we get demo. This should all hopefully sort of be working. Gonna go watch YouTube. Thank you for coming for a little bit at least. So let's go. We're gonna go place block 16. Cool. Now we got this. So if we go ahead and we say create face, we add a new face. We should see it highlighting, but we don't. That's not good. Okay, so why? Oh, because I have to select a face. Duh. There we go. Okay, cool. So now it's highlighting. If I click that, it should add those, and then we should see it continue to be highlighting, but it did not add those. Why did it not? Let's hit a breakpoint inside of mouse left. Okay, so we do that. Cool. So we do get into here. What is the normal? Okay, so it did get it. It says front. So it did get the correct normal, at least. Then we go through here. Okay, yeah, so it's definitely 240. Whoa. That shouldn't be 240 though. So that's totally wrong. Wait a second. Do I have something wrong in here? Face working on equals -1. Face normal, none. Then when we do this, let's see. Okay, yeah, face working on dot index equals I. That should never be 240. It's kind of weird. Let's do this again. Let's see what happens. So if we do the first time, 16, do this, create. Let's add a face, click 0, click there. Okay, what is our face data? Okay, so index 0, that's correct. Normal is none, that's also correct. So now, since the normal is none, we should enter here, right? Okay, we do. Then we should get front face, so we do that. Then what do we get? Face data is now index 0, normal is front. Cool, so that's all good. Then we go through here. We do all that. Okay, current block index equals 240. Ah, that's wrong. This should be face data dot index. Okay, so we just replace these. That's all good. Then we will remove that. Now we should be good. So let's see if this works out. What are we trying to accomplish? We're trying to accomplish so that we can add different faces to our cube so that we can create textures for this cube and everything. So that's kind of very high level, super quick. Okay, cool. So that's working at least. So I clicked here. This is now staying. We should be seeing red if I point in the wrong direction though, because that's Z fighting. We can ignore that. We should be seeing red though if I'm on the wrong face, because we shouldn't be able to highlight these. If I click here, it doesn't add it, which is good. I shouldn't be able to add these since we're only going this direction. It's just not changing the highlight color. So I think I have something up here, which is, oh, it should be right here. Okay. Yeah, okay, so if cube is occupied and face data normal equals bottom and that. Okay, so that's all good. Okay, then we check to see if it's in the right direction. We set it to normal, we set to true, then we say if it's not none, face in right direction equals false if that stuff. I think I see the problem, or at least part of the problem. Let's see if we hit any of these breakpoints real quick. Okay, so if we do this, let's do that. Actually, we probably want to put it in here instead. Okay. So let's place that. Do that. Okay. So if I hover over here, cool. So I hovered over there. We hit this breakpoint. Highlight color should be this. Yeah. Okay. Yeah, it looks like it did change that. One. Okay, that's like a yellow color. Did I get the wrong color here? I did. Why is this yellow? This should be red. Okay, I think that was just the wrong color. That's all that was. Okay, let's go back up here. remove those. We still have a problem though that we'll check out in a second. Yeah, that was definitely wrong. Okay, sorry. So that was just wrong color. Let's change that to CC. Now, if we try and go to a face that's not in the same direction, it should turn red when we're highlighting. So we do that, paint face, or I guess create face. That. Cool. Okay, so now it goes red if we're not in the same direction. But I think it'll be yellow if we point to that one. Yeah. Okay, so it's still yellow there. We need to fix that. Which we can do pretty easily. Sorry. Okay, let's do this. We can do this pretty easily just by doing something like this again. So what we'll do is we'll say if face data dot normal equals face normal front and not that. Yes, I think this is what we want to do. Then we want to do this. Okay, so we'll do something like that instead, which should fix that bug. And then we can continue on with this, hopefully. And then I can explain what we're doing a little bit better for anyone who's joined a little bit more recently. Okay, so let's just fix this real quick. Let's do parentheses around that. So if it equals back, and that was -1, that's wrong. Let's just go ahead and do this real quick. Place these. Okay, and I guess all we need is like that stuff, right? Okay, so we'll do that. Paste, 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 and paste. Okay, so back, this is top, this is bottom, and this is right and left. Okay, so now if we run this, we should get the correct behavior, and then we can talk about what's going on a little bit. Mostly the correct behavior. There's still going to be some bugs, but it's fine. Okay, so we create that face. If we highlight over here, that's wrong. We can't add that because it's not pointing in the same direction as that. Can't add that one either. We cannot add that one either. If we click here, it doesn't do anything. Cool. But if we were to, and I guess technically this is wrong. Okay, so if we actually switch to paint face, you'll notice that disappears, create face. And I click face 0, it should reappear. So we're gonna have to fix that too, because it should persist. If we go here though, and I add a couple blocks here, and we go back over to here. Okay, so if I do that, it should add it, but it's not. Okay, yeah, it's adding it there. Cool, so it's adding it there and there. We've got some buggy stuff going on. I've got to check out what's going on here. Okay, let's talk about what we're doing first real quick. Right now, if we place a block, we can like do this, and then if we go to block painter mode, we can start painting on it and stuff. But the problem is when we export this, we don't know where the textures go, right? Because basically, if I do that blue and that green, basically, these could all be different textures, right? This could be a different texture, this could be a different texture, and this could be a different texture. And so I need a way to determine which textures to apply to which quads. And so if I give the user a way to create faces, we can do something like this, where we say, okay, this is one face. So now I know all the pixels on this face go to one texture. And so then I can do some math behind the scenes. And when we export this, we can export those pixels as like a texture. This looks neat. Thanks. It's turning out pretty cool. So basically we'll be able to like do that. And then you can see, this is where it's like, it's breaking kind of. So if I hover over here, I kind of know why that's disappearing, but technically it shouldn't. So we'll have to fix that, which should be pretty easy. But basically then if I add a new face, so if I go to that, you can see it's disappeared, and we should be able to like add something else here. Sorry, excuse me. So yeah, we'll basically be able to like then say this is another face and then this is another face, right? And then we can just go on and do that. And then what we'll do is we'll also be able to apply textures. So then we'll be able to like say, hey, I want to apply this texture to this face. And so I want to add in some sort of way to do that with the GUI. So that's where we're heading towards. And that's the reason we need this. If I go back to face 0. Okay, so if I go back to face 0, you can see that this is highlighted. If I click here, it's fine. Face 1, nothing. Face 0. Yeah, that's good. Dezu Jin, thank you for following. Good to see you. But if I go to paint face, then go back, it's, oh wait, face 0. Yeah, it's gone. Why did it disappear? So it shouldn't disappear like that. But I think I know why it does. Yeah. Yes. Okay, I think I do know. Yes. What we need is we need a vector here. I think this is all that's happening, yeah. So basically we just need like a stood vector of face data, faces. Okay, and then when we say add face, yeah, when we do this, we'll say faces dot push back, or I guess we could do like in place back. Index is going to be number, I guess we could just do faces dot size. And then what's the next thing? We also need face normal. Okay, so we'll do that, and then we can get rid of that. This needs to be face data. Okay. Why does it not like this? Unsigned long to int. That's better. Okay, we should never be going up that many faces anyways. Okay, so we do that. Then this can be faces.size. And then this can be equals, I mean, faces I.index, which should be this thing that we want. And then normal is going to be that. Okay. I think that's all we needed to do, and that should fix it for us. Let's try this now. So that should make the state persist. Oh, no, it's not going to make the state persist completely yet. Set face working on normal. We need to fix that too. Yes, okay, so we also need to do like faces, face working on dot index equals normal, dot normal. Okay, so that way we actually save that state. Cool, so now we should be good. This should persist the state. Let's see if this actually works. 1 by 1 Rubik's Cube, exactly, right? Okay, so place block, 16. We got that. Block face painter, let's just do colors. Cool, and then if we go and do create face, add face, that's 0. We can't place it anywhere else now. Let's do this one. Okay, cool, so that's working. And then if we add a third up there, cool. So then if I go back face 1, it correctly highlights that face. We can't place it here. Face 0, it's correctly highlighting that face. We'll fix it so that it doesn't do that blinking on and off when I move over here. Should be pretty easy. And then if I switch off, so if I go to paint face, we don't see anything. We can still change colors and stuff because colors don't really matter. That's gross. That's better. Now if I go back here and I click 0, okay, yeah, then it's highlighting this one again. 1, it's highlighting this one. You can't really tell because it's yellow. 2, highlighting that one. Cool. Okay, so that state's persisting. We've got that settled. That's kind of gross because you can't really tell it's highlighting that. Yeah, well, I'm not sure what the best way to fix that is. I mean, you just can't really do much about that, I guess. Maybe like a border around the face too would be cool. I don't know. We'll think about that. Okay, so I'm trying not to like sniffle into the microphone too, so you guys don't have to hear that. We've got this. Maybe semi-transparent color on top of actual color. Yeah, and that's what it is right now. You can kind of see that where like this isn't the same red. Like it's a little purplish. We can turn down the transparency a little bit. Let's do that real quick. There was something else too that was broken. That was like, we should fix. What was it? There was something else. I thought I remembered, but I can't remember now. Oh, it doesn't highlight the stuff when we're not. Okay, yeah. So let's do it so that it draws that stuff no matter what. Yes. Okay, so we want to do something like if that and well, actually, I guess we could just say if it equals face mode, create face. Okay. And then what we can do is we can just draw highlighted faces. And then we'll do a function up here, which is, well, we'll just do it below this. Static void draw highlighted faces. Okay. And then we'll go down to handle create face. Okay. And then we will go and say this. And we'll just copy the code that does the drawing down to there, which I'm probably going to have to copy all of this and then just take out the parts we don't need. Yeah, so we'll copy all of that. And we will just take the parts we don't need, which I guess is we don't need the raycast at all. So we'll get rid of that. We do need that. Oh, and I think that's it. Yeah, we just draw the face there. Okay, cool. So I think that's all we need really. And then we can get rid of all this. So get rid of all that. Cool. So that's all we need. Let's turn down the transparency on that to like, I don't like this. Okay, let's do this. Highlight color dot A equals 0.5. Okay, that's much easier. I don't like thinking about alpha in hex. Same thing up here. And then what we can do is we can now remove the drawing code that was in here. Yeah, so we can now remove this because that's taken care of. Okay, that's all good. And we should be good here. Cool. Let's do the same thing here too. Okay, so that should be good. Now it shouldn't blink out when we hover onto this panel. So if we go 16, create face, add new face. There we go. Yeah, that's a little bit better. Semi-transparent, a little bit more. So if we do that, you can see that's red. That's yellow. If I hover over here, it's still there, which is good. And then if I hover over here, it's still there. Okay, so good. Now that doesn't disappear, which was kind of jarring. If I go to face 1, though, it disappears because now we're on a different face. And now we can't draw there. If we go to paint, we can go ahead and paint. Let's go to yellow. Make sure that we can still see stuff a little bit easier. Face 1. Yeah, you can see it just barely brightened it up a little bit, right? If we go back, you can see it just barely, which is good. It's not ideal, but hey. And you can tell it's like totally transparent now. So if we do that, you can kind of tell, which is good. Okay, that's good enough for me. So now we have a way to create faces and add to those faces. I think that's pretty much all we need to do now. Now we can actually work on the exporting, which is going to be the next big part. So let's get the exporting done. That way we can export and then import and hopefully get this stream to where I actually wanted to do, you know? Let's also just make sure this works. So if I go like delete some blocks in here, right? Let's just do that. And then if I were to go back to here and say create face, and we click face 1, we should, yeah, you can see if I actually go down here. I can actually add here, but I can't add here. This is wrong because we only support 16 by 16 per face. So this should technically take it up. I should probably add it so that like if you try to add extras here, it doesn't work. And then we also need a way so that you can like remove faces. So if I click here, it's still working because we kind of don't have that embedded yet. But yeah. And if I was like clicking here, this basically shows though that you can only place faces in the same normal direction. So like, yeah, we can't do here, but we can do here. And it might be good too, like to show all the faces. So right now we only show those. It might be good to like show these in a different color just so that you know that like it exists. While you're working on this one, you know like this is already covered by another face. So that's all stuff we can add eventually. Hopefully this makes sense, guys. I really hope it does. I'm going to take a break in a minute, a bio break, and we're going to, when I get back, work on exporting all this data to a file, a binary file format, so that we can then re-import that data in a manner that's just good, right? And we'll probably work on the simplest thing ever, which I'm kind of curious what happens if we do this too. If we cover that stuff back up, does it, if we go back here, yeah, cool. It kind of just gets rid of that stuff. We're going to be working on the easiest thing ever though, which is just, oh, cool. And it saved that stuff too. So those are still technically good. The cube is the first object we're going to try and export import. So yeah. Hey Sock'em, if you didn't plan on this, mouse wheel is incredibly useful for extrude faces default keybind. That's a good idea. I originally had it here. Let me pull this up. So we've got some to-dos in here. This is done. We can just do tilde tilde. So we were originally going to do it like controller shift to extrude faces, but mouse wheel might work too. So let me just add a little mouse wheel might feel better for extruding in direction of normal. I kind of like that, yeah. Because then you can like, yeah, I do like that. I did a ton of mapping for the game Diabolical, which was a block editor in game. They have quite a few good ideas in it. Free game, you can play it, Epic Launcher. Okay, totally worth the time to analyze the editor. Thank you, yeah, I might check that out just to see if I can like figure out cool keybinds and stuff for us, but I like that idea. Hilbert curve, what if you do what Fusion 360 does with the construction planes and extend faces a little beyond its bound? This is actually really cool stuff. Thanks, Essie Woods. And extend a little bit beyond its bounds. S4MY Hacker. Somi Hacker? Sami Hacker? I don't know. Thank you for following, though. It's good to see you here. I have a custom keybind file that's blazing fast. Totally worth the time to analyze later. Yeah, we could definitely, I will definitely take ideas. That's something we'll probably do closer towards the industry. And we'll take ideas so that I can sort of start implementing those. These are some of the other ideas. We did this. We're working on this. Working on this. Pretty much done. Did this. Kind of working. Not really. Working on that. I need to do that. This is done. Cool. So we will definitely take ideas and add them to our idea to-do list because that is good. Let's just move stuff around a little bit. And then I'm going to go for like a 5-minute break and I will be back. Let's see. Do that. We'll move this stuff down as well. Cool. So that's pretty good. We got that stuff knocked out. Why isn't it like that? I don't know. I don't care. I think it doesn't like that just because I don't have like a heading. Yeah, now it's happy. Okay, cool. So we will add stuff to the to-do for sure. We'll take those ideas in a little bit. Yep. Sami Hacker. Ah, that makes sense. For visual, it's Hilbert curve. You might have to expand on that a little bit, but yeah, we'll think about that in a minute. If you want it, I could share it, but we'll need to understand the editor. Main core behind it is QER for all keyboard controls, nudging, extruding, etc. all go in there. Huh. That would be cool. You could probably join our Discord too, and we could kind of communicate in like the Coding Minecraft channel or something like that, and kind of go back and forth on this if you want. But yeah, I'm gonna take a quick break, guys. I will be back in just a minute though. Let's put on some music while I am away. Play this again. I'll turn that up a little bit, and I'll be back in a few minutes, guys. So see you in a few minutes. All right, guys, we are back a little bit earlier. I meant to switch that to just the waiting screen because never know how long it's going to take, but usually like 5 minutes. Okay, so let's just go back. I've still got this running. So we want to work on exporting, importing this stuff now. We're going to export, import two things, which is important. First thing we got to export, import is the block type itself, which is going to consist of all the vertices that compose this block, which in this case, so we're going to have to do some sort of greedy meshing type thing here, right? Because in this case, we only want to export these four, and these four. And the way we can sort of do that greedy meshing is by using these faces. So we're going to have to ensure that all the vertices have an associated face, and then we're going to loop through each face and try to mesh together the cubes, if that makes sense, into as few vertices as possible. So that's the basic idea. And then we're going to export it to some like binary format or whatnot. And then the second phase is we need to actually export the colors to textures. So then we go through the faces one more time and we get all the colors together using that greedy mesh data that we've already generated, right? Ideally, what would happen is this would be 4 vertices. And then what we could do is export these 16 by 16 pixels to one texture, and they would just be outlined exactly how it looks up here. So that's the plan. Now, how do we do greedy meshing and all that stuff? That's the hard part. So we'll go ahead and take a look at all that and hopefully get it working pretty easily. So first phase, I think, is a little bit easier. We'll just kind of figure out, let's see if we can greedy mesh this stuff. So yeah, let's just, we'll throw a cube. And then what this is really is this is 16 by 16 by 16 cubes. It's really mini cubes, right? We've got all this space. You can see there's nothing in here though. So let's see if we can first create a file that contains only 8 vertices, because that's all we need. I mean, technically 36 because we have 6 faces. But for now, let's just focus on the greedy meshing and see if we can get that part down. Also, let's commit this stuff real quick first. Git bash, git add dot, and get face creator mostly done. That is that. HomePod777, thanks for following. Good to see you here. Okay, cool. So, trying to think of what the best way we're going to do this is. And the first thing I want to do is let's take a look at our current vertex definition inside the game. So if we look at block format.h, okay, yeah, block map.h, I guess is what I meant to say. If we go down here, we get, yes, so this is what our vertices currently look like. So currently, I have a fixed amount of faces, which is 6, right? We have 6 faces for one cube. Do I know OpenCL? I do not. I think that's like compute shaders and stuff, right? And something I want to learn, but I haven't taken a look at yet. So this is going to have to change a bit. Hey, sent a donation. Not sure if it came up. Shark Tank. Oh, it did come up. It looks like it came up when I was on the break. Thank you, Shark Tank. Tipped $1. Decided to start working on your own Minecraft project, but put a bit of time into it and try to understand how to start Java, but I'm a bit stuck on the OpenGL part. I know you made tutorials, but is there a way for you to privately help me? Thanks. So if you're asking about like private lessons or anything like that, I'm sorry, Shark Tank. I am not doing any sort of things like that just because I have a full-time job and stuff, and that's my main source of income. If I do ever decide to do sort of like private lessons or something in the future, I could potentially. But we do have a great Discord with a lot of helpful people, and I go in there and try and help people out as well. So that's free too. So definitely join the Discord. And if you have questions, I know all the people in there are great and would love to help as much as we can. As for learning OpenGL, it takes a bit of time. It took me like 2 to 3 years before I fully started understanding it. But if any of you are interested in learning OpenGL very well, seriously, I cannot recommend this enough. This thing is great. Like, buy this book, read it, do the stuff that they're doing, because it really will help out a lot. So, OpenGL Super Bible 7th edition, comprehensive tutorial and reference. It is a tutorial. It teaches you how to do stuff. I know a lot of people don't like reading these days, but seriously, these guys are super smart. The authors, let's see what the authors have done. Yeah, so this guy is an AMD software architect. He works on the OpenGL specification, right? This guy's a senior software engineer. This guy is a director at NVIDIA. So the authors of these books know what they're doing. They are the writers of the specs. So seriously, this is the best resource I can ever recommend. Yep. How does that book stand out compared to learnopengl.com? It is way more comprehensive, and it's great. Yeah. It's learnopengl.com is also great. I'm definitely not picking on that or anything. It's great if you want to get started pretty quickly, but that book is just a lot more comprehensive. It fills in the gaps that you kind of get going through Learn OpenGL. So, yeah, can't recommend it enough. So anybody who's interested, definitely check it out. It's like $40. It's not that expensive. It's like if you were getting a game, just don't get the game, get the book, and then you can learn. So, or check libraries. Local libraries might have it too. Thank you for the share. We'll definitely check it out. Olivia the Vampire, link to the book. Sure. Let's do that real quick. OpenGL Super Bible 7th edition. Definitely check your libraries too, because they might have it for free instead of going out and buying it. But there is the link. Yeah. Okay, so. But yeah, thank you for the donation, Shark Take, and that's sort of the best information I can give you on all that stuff. So, currently we have this. That's not going to work. And we have this. Yeah, we're going to have to like change up that completely. So I'm not going to worry too much about how it currently looks here, because this is mostly going to change, which is fine. Yeah, I'm okay with that. Let's take a look at the shaders too real quickly though, because they have a lot of information here. I just want to make sure we can export all that stuff. So we've got a texture ID. Let's just drag this over actually, because this will be a little bit better. Okay, so right now we got this vertex offset index. This is going to disappear, and we're going to actually use 15 bits, I think I said. So we're going to have to do some reorganizing it. I might just put it down here and place this pose XYZ up here. We're going to have to do some reorganizing and stuff, but yeah, it's all good. But we got that. Texture ID, that's going to have to be there still. That's fine. Pose XYZ, that's fine. Face normal. Yeah, that's fine. We still need that. Biome color, that's if we want to color it by biome, we can add stuff for that. Light level, skylight level, that's fine. Those are dynamically generated. Same with light color. AO, okay, so ambient occlusion is something we can now embed within these vertices, and then we can add some extra information. Yeah, so we do need that. Rotation type, that's fine, that's dynamic. So OpenGL is nothing compared to something like Vulkan DX12, as it doesn't hide all the lower level stuff, but that also makes OpenGL DX11 good to start learning. Compute shaders are not necessarily OpenCL or CUDA. Gotcha. It's basically the same concept, though, is what I was thinking. OpenCL, CUDA are basically, you just want to execute arbitrary programs on the GPU. So same thing, just not exactly. Yeah. Shark Tank yet is the most confusing for someone just starting. Okay, so yes, we're also going to need UVs embedded in here somehow. And that was something else I was thinking of. So UVs, how many, so per texture and vertex, what are our UVs? We could have up to 16 by 16. Right? Okay, let's 16 by 16. No, come on. 16. So 256, but we've also got 4 possible positions per face for a UV. So we'll call that 1024. How many bits is that? That's like 2 to the 8th, right? Or something? No, that's like 2 to the 10th. Yeah, okay. So we need 10 bits for that. So why did I close OneNote? I don't know. So we need 15 bits for the position data. Oh, and it opened up over here. I was looking for it. So we need 15 bits for that, and we need 10 bits for that. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We could probably squash the UVs into these first 10 bits. And do I have 2 bits? And then we could squash the ambient occlusion into these 2 bits, and then we can place the 15 bits here. Yeah, I like that. Oh, cool. And then we have 4 bits, so we can move the rotation type here, pack that in there, and then we got 15 bits here. Cool. So that's our plan. Well, let's see if we can do it. So let's move that out of the way. Basic plan is good. What the heck? It just closed OneNote again. I guess Windows doesn't want me to have OneNote open for whatever reason. Okay, export, import. That's what we're working on. Let's do it. So we're working on greedy meshing first. Okay. So for now, we're just going to have like static void export block type. Okay. This, yeah, we'll do it like that. That's fine. Sorry, guys. I am like, my throat, I lost most of my voice earlier this week when I got sick, and it was like very bad cold, almost strep, which is why I'm just like clearing my throat constantly today. So we will have this. Let's put it below compile geometry because it's going to be pretty similar to compile geometry, which is essentially just a meshing algorithm. So we'll do that. We will go down here and we will call this, why did that go very weird? And we'll call this export block type. Cool. So we got that. Let's just copy this for now. It's clearly not going to be exactly the same, but it's going to be similar. And basically what we need to do is we want to go through the different faces. Well, I think the first thing we want to do is get like unique vertex positions. Let's compile this again and run this. So we're going to do this in a couple of phases, I think. How do we want this to work? We've got this cube here. Let's go ahead and paint a couple things. Red, green, blue. We got this cube here. We have 8 unique vertices. 1, 2, 3, 4, 5, 6, 7, and then 8 is back there. We have 8 unique vertices. And this will always be the case, right? We will always have some amount of unique vertices if we go back here. So even if I were to say, do something like that, right? Now what happened is we still have a certain number of unique vertices. We just have 1, 2, 3, 4, 5, 6, 7, 8. And then we have 9, 10, 11, 12, 13. And if we look in here, 14, 15, 16. So now we have 16 unique vertices. I think what I want to do is first we get the unique vertices, right? So we figure out which ones are unique and are needed. And then based on that, we can do some sort of greedy meshing, maybe. Because then what we want to do is we want to basically say like, okay, this is cool. Now we can paint onto this and I can explain in detail as I'm painting here. So then what we can do is we want to say like this is going to be one quad, right? So when we do our greedy meshing, this will be one thing. And then ideally what we would have is like something like, whoops, this would be another face right here. And this is kind of weird. Yeah. Then what we would have is we would have like, this is another one. And I can't draw at all. I just totally went over that. It's gonna be slightly different. Close enough. Okay. And then we'll have this. This is a different color, but it's okay. That's not what I intended. So we got this. Keep drawing. Come on. This is what we want to happen, right? This is how I approach designing algorithms because it's the easiest for me. I want to visualize it, know exactly what I'm trying to do at a high level, and then we can go further low level and figure that stuff out. Tinspin, thank you for following. And HomePod77, I think I saw that earlier. Hey, Sock'em. Just sent the file on Discord channel, #CodingMinecraft. Like I said in there, happy to help with ideas or questions about block editing, mapping, workflow. Just ping me anytime. Cool. Thank you, Sock'em. I will check that out. Probably a little bit later today because after streams, I usually like take a break for a little bit, but I appreciate that and I will definitely be checking that out. Okay, so this is essentially what we want our algorithm to do. Technically, this will all be one color, but that's fine. We want it to say, hey, I can see that there's only 16 unique vertices here, right? We counted those. And we can break this one face up because it's going to see that this is like all part of one face or something, right? And I wanted to say like we can break this up into a quad here, a quad here, a quad here, and a quad here to do like, you know, the minimal number or whatever. And then what it would do is like, and then we would have one more quad for this face, which is here, right? We'll do that like pink, right? So then we would have one more quad there. And that's all one face. But instead of taking up like a ton of vertices, we can make this a section on the texture. We can make this a section on the texture. We can pack this into a section on the texture and this into a section on the texture and then that. Sam, but you can merge only same types of blocks, even include texture. What is it you're trying to do, if you don't mind asking? So what we're doing right now is we're building like a block editor so that we can import different types of blocks. So, you know, a fence block is one type of block and everything. And so to do that, we need to export it to a format that we can then import it into the game. And I want to export it in the best way possible. Sam, can you expand on that a little bit? You can merge only same types of blocks, even include texture. These should all be like the same blocks. I'm not quite sure what you're saying there, but yeah. I see. What this block builder will be an in-game feature or just for you to build the blocks you want? This is just for me, which is why I don't care if it's pretty. It just needs to get the job done. And my brothers, they'll also be using this. So what's the best way to go about this? Do I just start looping through the blocks and then I say, okay, let's just start here. And then I just say, let's see how many faces we can get. And so then I loop, and we just kind of greedily, that's like what a greedy meshing algorithm is. So then I loop, right? We go 1, so we keep adding. Yeah, we can keep adding. Let's do this a little bit more algorithmically. And then we get to here and we try to keep adding. We can't because of this. So then we go back and we say, this is the first one. Okay. Then we say, we also need this face. So what we do is we go here. Okay. We say we can add that row. Can we add this one? So then we go down, we keep adding, and we keep adding. And eventually we get to the bottom because that's how far we can go. Okay. So then that would be our second face. I will look at that in a second, Sam. Sorry, I'm just going to keep going on my train of thought here. Then I guess the next one that we skipped would be this one. And we would say, okay, we can just do that. That's that face. Then the next one would be this one. And so we could say, okay, we can go here. And then we would just keep going down. We would get that. And then this is the last face that we need to do, which do like orange. We'd say, okay, we can go here, and then we could say we can go down. And then that's how we would break up the faces. Sam, when you're traversing blocks for greedy mesh, you need to check if they can be merged, and in the condition, you need to have all your properties that have different properties in the vertex input. So different textures, AO value, color will not be merged. I see what you're saying. The textures and the color are fine because for that we have this face creator, right? So we already know that like if I do this is one face. So we already know that. Like I don't have to worry about this. So we know this is one face, and then that also means this is one texture. So I can mesh this together with confidence that the colors can be merged because these will be converted to UVs. So that's fine. I'm okay with that. But ambient occlusion, you're right. We need to figure out a way to do that too because we can't merge. What Sam is saying is like basically if we have something like, delete that. Here we go. So I'm trying to think too. Can we do something? Yeah. Okay. So what Sam is saying too, I think this is what you're saying, Sam. You can correct me if I'm wrong. Basically, we can't have this be one face because this ambient occlusion for that vertex is different than all of these vertices, but we can have that face. And then we can have this as a face. Yeah. Okay. So that's, I think, all we have to worry about is the ambient occlusion, and then the textures will be taken care of. So that's one extra constraint we have to deal with. Because these ambient occlusion levels should all be the same. Yeah. And we can do that as we're checking dynamically. So that is one last constraint we have to worry about. So, yeah, so let's go through this step by step one more time. And this is how the algorithm is going to work. So algorithm, step one, we start at like some corner of the block, right? 0, 0, 0, which might not be this corner. It's probably actually going to be down here or something. We start down here. Okay. We loop through, we go like according to whichever direction we're going. So we're checking this face. So we're only going to iterate, whoops. If we're checking this face, we're only going to iterate in this direction and up and down. We're not going to go back and like that way because that doesn't make sense. We're only checking this face. So then we go through, we say, okay, is this face visible? Does it have the same ambient occlusion levels? If so, we add it. If so, we add it. Okay, we continue, we keep adding. That's good. Then we go up. We say, can we add all of these? So I guess like this would be a temporary state. We would go through, and then if we've gotten to the end, so this is the same width as the strip below us, then we can add this to the face. So then we say, okay, that one gets added. And we continue doing this. We then check the next strip. Can we add this whole strip? If so, this gets added. That's the next strip. Okay, then we go up here. Can we add this? Yes, we add it. Okay, we continue doing that. And eventually we get to here. So then we would say, can we add this whole strip? Uh-oh, no, we cannot. And then we say like end. So then this is our first greedy meshed face. So as soon as we hit that breaking constraint, we can't add a whole strip, we get our first face. Then we restart the process. In tin spin, I will answer that in just a second, so don't worry. Don't want you to think I'm ignoring people. Okay, so if we go, so we've broken we've broken it. So now we start new face. Okay, so we go, how far can we go? We can go up to here. Okay, and then we stop because we hit this. We can't keep going. So then we go, can we add this? Yes, we can. So we add it to the strip. Then we go, can we add this? Yes, we can. We add it to the strip. Same process, right? So this is a loop. We continue. And then we hit the next breaking condition, which is we've hit the top. So this is our next face. Then we need some way to keep track of what the next position would be, which I guess would be this cube. But since there is no face here, technically, there's no face here, then we would skip it and move on to this one. So then we would go, okay, let's try and add that face. And then we would just keep going up, right? So then we are going to fill this. So this is like the next XY position. We can't do that one. So we go to the next XY position, which would be this one. Let's do like cyan. Okay. And then we would check, can we add this? Yes. Let's add it. Can we add this? Yes, we add it. Okay, so then we keep doing that. Then this would be the next, right? Okay, so technically the next XY position would be here, but that's already added to a face. So then we would keep going and then we would hit this guy. So we would say here, can we add this? No, because this is already part of a different face. So then we would go and add that. That's our greedy meshed face. We'll see if this works. I don't know. We're going to see. Little guy, Gabe finally fixed my Minecraft clone. Sam fixed it for yesterday for me, but it damaged during shipping. Well, that's great. Hopefully you can keep working on it and stuff too. Tinspin, is the ambient occlusion code available on GitHub? No, because the code is kind of private right now. I might open up like a Patreon benefit at some point where you can take a look at that if you want. The ambient occlusion code just follows this article though. So it's link in chat. So that's the article. It just follows this pretty much exactly. Like you can see, I literally have like the same stuff as him here. If we go to this, it's literally the same thing that he has there. So just changed up a little bit. And there's kind of like an algorithmic way to get the correct size to check, which is a little tricky, but yeah. Which is pretty horrible. What, the article or that algorithm especially? I don't know. Sorry, trying not to sniffle into the microphone. Okay, so I think we've got kind of an algorithm that we want to do. The article, yes, agreed. The article is pretty horrible, but it does outline it enough that like if you spend enough time, it works. And then he talks about greeting meshing here, so yeah. What does he say? It's actually quite easy to integrate this. The key idea is we just need to merge facets which have the same ambient occlusion across each of their vertices. Okay, cool. So that's exactly what Sam was telling me too. How much performance does it take? It takes no performance. I mean, it's just part of the meshing algorithm, so it doesn't actually take anything. Like you're not doing post-processing or something like that. It's just if we look at the shader, I basically just get that ambient occlusion value and then just multiply it by our RGB. So no performance hit. Yeah. From the article, conclusion, adding ambient occlusion to a voxel game is super easy to do. It is super easy if he would have written a better article. But yeah, you mentioned in the article you got smooth lighting from the same tech. Yes. And the smooth lighting article is actually much better than this. I think I have it saved somewhere here. Let's see. Yeah, lighting. Okay. This guy. This is on the Wayback Machine because sadly this article isn't here. This is a great article that's actually much better. So yeah, 13 followers to 1K. We're almost there, guys. Yeah, so you mentioned in the article you got in the article equals video. You mentioned the video you got smooth lighting from the same tech. Okay, yeah, so smooth lighting, you can basically merge these two concepts together and it's almost the same. So yeah. I guess this is just technically for regular lighting, not smooth lighting, but it does get you most of the way there. Okay, greedy meshing, that's what we're focusing on. So let's go back down here. So let's focus on one face for now, I guess. Seed of Andromeda, following that project when it was still in works, but they stopped it. Yeah. It was very good. I wish they wouldn't have taken the website down because that was easy. Honestly, you all are a bunch of geniuses. No, it's just a lot of work and pain and tears. I don't think I'm a genius for sure. It's just you keep banging your head against the table and eventually you get to a solution. Tinspin, so you can do both with forward rendering or does it need deferred? I think Sam's doing forward rendering with these techniques, right, Sam? So you can, or not forward, I'm sorry, deferred rendering. I'm doing forward rendering just because like there's not any particularly complex calculations in my thing that need deferred rendering, I don't think. So like I just do it all one pass. Sock'em, how long have you been doing this? Definitely looks like you have quite a few years of experience. So I've been programming like 8 years now, I think. And then I've been doing OpenGL specifically since actually I can tell you guys exactly. So I've been doing OpenGL for like 4 years, but I've been doing focused OpenGL where I've like actually been trying it since I released. this video. Let's see. Games with Gabe. I'm searching myself. That's not great. Games. There we go. So if I go here, playlists, let's see. Because I can get the exact date for you guys if you want. If we go into here, I've got a video. Is it this one? Wait, let's see. Switching languages. Font rendering. I thought it was in here. It might be somewhere else. I don't know. But basically when I started the Mario series, this thing is pretty much when I started doing OpenGL like pretty seriously. And this was March 31st, 2020. So like 2 years. If you focus on it for like 2 years, I guess you can. And if you get that book, it'll speed it up way further. So get that book because it'll shortcut life for you. I wish I would have gotten it sooner. Yeah. Okay. We're going to work on one face for now. And then if we can get that working, we can extend it to multiple faces. Yeah, I think that's the best way to do this. So, yeah, I think what we're going to do is we're going to take this in slices. And I'll look at some other solutions after I implement my solution because I know it's not going to be the best, but this is going to be the easiest. So what we'll do is we'll take in slices, right? So first, what we'll do is we'll take XY slices. Take XY slices first. So we'll go for, we'll iterate over our Z. We will iterate through Z, and then what we'll do is we'll go like according to XY for int whoops. This is not going to be iterating over the data in the best way possible. This is kind of bad for cache because this ideally what I would be doing is YXZ. So this is kind of gross, but it's the easiest way for now. So this is going to be like begin new greedy mesh. And then we're going to go through here, do our greedy mesh for this specific slice, and then we can add it to our list of slices. List of slices, right? And I think that's kind of how we'll do this. Trying to think of what the best way to do this will be. I don't like this. Let's look at that article real quick. I'm thinking of a specific article. His last one wasn't very helpful, but maybe this one will be. So smaller meshes are better meshes. Yep. Latency can't be too high. Yep. Stupid method. Culling, which is what we're doing now. And then greedy meshing. Yeah, so this is exactly what we want to do, right? Okay, first observe that it suffices to consider only the problem generating a quad mesh for some 2D cross-section. The slices. Okay, good. So at least I got this far. That is, we can just sweep the volume across once in each direction and the mesh each cross section separately. Cool. So I've already gotten there. Like that's one thing done. Yeah. This reduces the 3D problem to 2D. Yep. And the next step, which is the one we're on, the hard one. Good to know that's the hard one. Is to figure out how to mesh each of these 2D slices. Yes. Doing this optimally with diffuse quads is quite hard. So let's reformulate the problem as a different type of optimization. We're going to define some type of total order on the set of all possible This is why I don't like this guy. Quadrangulations. Just call it something simple. Why are you doing this? Okay. And then pick the minimal element of this as our mesh. Minimal set of this as our mesh. To do this, we'll first define an order on each quad. Okay. Sorry, I'm just kind of skimming this real quick and then I'll see what I think. So he's basically just proving that it's better here. And then he doesn't talk about how to actually do it. Okay, well, that's great. I love how he says this is the hard part. So how do you do it? Well, let's just, okay. I guess this is, by a 2D quad mesh, here we mean a partition of some set S into a collection of quads. Now let's define a total order on these quads, given x0. Okay, given the x and the width and the height, we can define the relation. So he's basically saying, how can we compare quads to see if it's better or worse? Okay, I'm going to reach out real quick. Joe of all time, you came up in my recommended and you seem pretty cool. Thanks. I love getting to watch people working on, getting to watch people code as someone who is very slowly learning. What you working on? We're working on greedy meshing for this Minecraft thingy. So, but yeah, thanks for the comment though. So we're kind of working on, I've got this block editor thing for my Minecraft clone, which is not going to be a Minecraft clone anymore. And we want to import blocks. And in order to do that, I need to have some way to turn this, which is currently a cube of 16 by 16 by 16 cubes. But really, this is just one big cube. So we want to turn this into one big cube instead of 16 by 16 by 16 small cubes. And the way to do that is with, if we take a look at this, greedy meshing, which basically, right, we have 8 vertices here as composed to what we have now, which is this. So that's basically what we're working on. So I'm reading this article, which gives some insight onto how to do this. And, okay, I think I kind of understand what he's saying. Kind of. So basically, he's saying we need to get the set of all possible quads, first of all. Then we need to find which quads are the best quads. Right? So he's saying we get a set S of quads, which are defined by the top left corner or bottom left and the width and the height. And then to compare 2 quads to see which one is better, we do something like this, which basically just checks to see like which quad is bigger. So yeah, this is super fascinating. What? This is so much more advanced than what I initially thought. Mega cool. Thanks. Yeah. We'll see if we can actually do this. But yeah, Joe of all time, thank you for following. Yeah. We shall see if we can actually pull this off. It is the plan, but it's kind of difficult getting all this stuff to actually work right. So he talks about it. Yeah, this is the hard step. And then he doesn't really tell us how to do this. Figure out how to mesh each of these 2D slices more formally. Okay, so what he says, the idea is we're going to define some type of total order on the set of all possible quadrangulations. So this thing, what he means by this is we are going to come up with all the possible ways we can turn this into quads. So if we were looking at, let's pull this up again. If we get a cube here, that's our cube. So what he's saying is we need to come up with a way we got that face, right? And then if we go here, do this. Okay, so let's go back to this thing. If we want to mesh this, definitely want to keep my eye on your channel. Seems super knowledgeable, and I absolutely love to learn more. Thank you. Yeah, I am standing on the shoulders of giants. I am not that knowledgeable, but the people that I read about and stuff are. So, and the people in the stream who help me out too are super awesome. So, but yeah, that SOA game looks so freaking dope. Why did they stop development? Oh, Seeds of Andromeda. It does look cool. Okay, so he says all the possible quadrangulations. What is that? That is basically saying one possible quadrangulation is, if we break it up into this yellow and pink. Okay. That's one possible quadrangulation. I think that's what he's telling us, right? Let's see. So we're going to define some type of total order on the set of all possible quadrangulations and then pick the minimal element of this set as our mesh. To do this, we'll first define an order on each quad, which we then extend to an order on the set of all meshes. One simple way to order two quads is to sort them top to bottom, left to right, compare their length. XY width height, where XY is the upper left corner, width height is the width height of the given quad, such that given representation of a quad. Oh, wait, okay, I think I see what he's saying. Okay, wait a second. No, this is a little bit easier than what I thought he was saying. So, given this XY, which quads can we come up with? Okay, let's paint this again real quick. Let's do that. 16. It's red. Okay. So, given this XY, we're starting here. Which quads can we come up with? Well, we can come up with, this is a quad, but we don't want to do that. That's kind of stupid. We'll go like the maximum length, right? So we'll keep going. We'll say that's the first quad we can come up with, right? Okay, cool. So that's one. What's the second one we can do? We'll do blue. We can also go down, right? So I guess the thing is we're going down now instead of right. And let's just turn this up a little bit so that make that a little bit easier. Okay, that's the second quad. Okay? So, which quad is better? Those are the only possible, right? If we go right and if we go down. Those are the two possible quads. Which one is better? This one is better because we can compare them using this function, see which one has the bigger surface area. We'll choose that. So then this is our quad. We choose it. That's done. And then we go back here. We go turn that down. Okay, now we're focusing on this part. So that's the first part. We've greedily meshed that part of this slice of this cube. Next, we're trying this one. What quads can we come up with? We can come up with this quad, and that's the only quad. So that's our quad. We're done here. Okay. Then we get here. What quads can we come up with? Well, we can only come up with this quad. That's the only quad. We're done here. And then we get this part. What's the quad we can come up with? It's just this quad. Done here. Let's do this pink. And this should be the optimal greedy mesh. We now have 1, 2, 3, 4 quads. I think that's basically how we do this. Okay, let's see. I think this is what we want to do. And then let's just make sure our assumptions are correct. So let's also do this if it was just a actual whole cube, right? So if we actually had, instead of this, it was just a cube, paint, 16, red. Okay, so instead, if we had like the whole face, we could only come up with one quad, right? Because if we go right and then we go down, it goes here. If we go down and then we go right, it goes here. Same quad. That's the optimal mesh. We have greedily meshed it, and it is what we want. Okay. So, Langors, don't remember it's better, but at least have good illustration. Oh, did you get a, oh, greedy meshing. Oh, cool. Couldn't you come up with a horizontal quad? Oh, sweet. I may check this out a little bit later. I'm going to keep going on this thread of my thoughts because I think this makes sense to me, and we're going to see if we can do that. Horizontal quad. Yes, I think I see what you're saying. But basically what we do is we're going to do this for each slice, right? So this would be our first slice, right? Then we would do it for this slice. And since none of the faces are visible, we would essentially skip it. We keep going, and then that's this face done. So we do that like all the way down. We have greedily meshed this face, which is the west face or whatever it is. Then we would start here. So then we would do the same thing, go slice by slice until we complete it. That's that face greedily meshed. Then we would do the same thing for this face. We would do the same thing for this face. And so we basically just loop through all of the different faces and we do the same thing. That way, if we have a block that's like in here, right? So then once we start working on the next slice back, this would be the only quad, and then we would greedily mesh that, which would just end up being like that, right? So I think this is how it kind of works. But yeah, let's do this. So what do we need to do in order to get this done? Ned Bolter, thank you for following. Good to see you. I meant when you had an intrusion, in one of the cases you said only had one quad possible, but I think you had two. Did I? So basically the way I'm thinking that we come up with quads is if, let's do that. If we do this, the way we come up with the two quads, so I guess like in each case, there's only going to be two possible quads. We get like, right, we would get this quad, which we get by going right as far as we can go, which is to here. Then we keep going down as far as we can go. That's here. And then the second quad would be, okay, it was the third one you think. So let's do this one more time then real quick. So then we go here. That would be the optimal quad here because we can go down. That covers more surface area. Okay, so for this one, we would get, if we go right, and then we go down. This is the farthest we can go down because this block would break that. Then if we go down and then right, so this is like the only one possible. So then get that. Okay, and then below green. So then we would move here, which would be we go right all the way possible, then we go down all the way possible, which is this. And if we go down and then right, couldn't you make one just to the right with a single row? So are you saying something like that? If that's the case, we could, but I'm going to exclude it. Yes. Okay. Yeah. So we could, but I'm going to exclude it because the way I'm saying we come up with our quads is we go right as far as we can go. This is one strip. Then we push this down as far as we can go, which would be down here. And then the second possible is we push down as far as we can go. Then we push right as far as we can go, which would be this quad. And then we continue, if that makes sense. And then the last quad we would get is here, which is just this. So this one would be kind of like what you're saying. We would have two possible. We would have one here. Then we would have the second quad would be, or no, even then we would have like, we push it right and then we go down. So it would just be one quad there too. Okay, I think that's how we do it. So let's do this. We need a struct quad. We need int xy, int width height. It's also going to depend on whether you iterate first over x or y. Yes, and that's why we're doing it in slices. We do it by slice, and then we iterate over every different face. So, yeah. I guess, yeah, we should do int xy vec3 normal. Or I guess we should say face normal. Normal. So we'll do that. This will give us xy width height and a normal. Do we even want to do it that way though? We think. So sorry, here, give me 1 second. I think we want like XY depth, and that depth will kind of be our slice index. And then what we'll have is we'll have like we'll kind of have like trying to think of how this works. Do we need that? I don't know. Yeah, I think we need the depth. And then we basically need, what I'm thinking is like a struct, which is like and this will have like a face normal, face, and then like a vector of quads. Okay. Yes, I think this is what we want, right? So we basically have this struct, which is a quad. Then we have XY depth, width, height. Then each face will have a vector of quads, which will contain the greedily meshed quads for every single slice within this normal direction. Okay, if that makes sense. So that's the plan. Let's move these up to the top of the file, because I will want to do some extra stuff with this just to make sure we're getting this right. So we got that. That's good. Quad, and we have quad container. And then back down here, let's do one slice for now. We'll say this is our container, right? Quad container. Container dot face. Yeah, okay. Equals face normal. We'll do front, which is X positive, which means that we'd be iterating along Z. Okay. Right? Yeah. No. Wait. Okay, I got to think about this. X positive is pointing this way, so we want to iterate along X positive in that case. So let's say this is right. Wait, is that right? Wait a second. Yeah, that's right. Wait. Yeah. So let's do that front. So the slices are actually going to be X in this case. And then we're going to be iterating YZ. Okay, so since we're doing the front, we iterate along X, and I guess technically we would want to do like 16 to 0 or 15 to 0. But we can get around that later. That's fine. Z. Okay, and then this is begin new greedy mesh. Okay, and this is the hard part, kind of. So we want to come up with two quads that we could potentially have. So what are our two quads? Well, we'll do quad Q0. Q0 dot X equals. Okay, this is where it's kind of hard to. Okay, sorry, I'm trying to think pretty hard about this. So first, we have like an XY, right? So int X equals 0, int Y equals 0. We're starting at the top bottom. And I guess, okay, let's call this quad X, quad Y. Okay, we're starting at the top left, or I guess this is the bottom left. Doesn't matter, it's the same deal. Then what are we going to do? We're going to say while quad X does not equal 16 or 15. I don't think it matters. I think we want to do 16. And quad Y does not equal 16. We're going to continue to iterate. Okay, I think I got this. We're going to have quad Q0 dot X equals quad X. Q0 dot Y equals quad Y. And then we want to do this first. So this is Q0, and then Q1 would be Z, then Y. So that, then that. So we reverse it. So quad q1 dot x equals quad x, q1 dot y equals quad y. Okay, and we basically want to start this. Y in this case, I guess, will be our y, and then z will be our x. So we'll say z equals q0 dot x till it's less than 16. Y equals q0 dot y. Same thing here. q1 dot x, q1 dot y. Okay. q0 dot width equals 0, q0 dot height equals 0. So we want to find out the maximum height first, since we're doing y here. I hope this makes sense, guys. It's kind of not making sense for me, but it kind of is, so we're just going by ear here. Okay, so what we'll do is we'll say for int y equals q0 dot y till y is less than 16, y plus plus. Let's see how high we can go. So right now our height is 0. For every y we go up, we can go 1 further. So we'll do that first. Okay. So what we do is we say, if the block is visible, if this face is visible, which face are we looking at? We're looking at the front face. For this block, then we can add it. I have some code down here to do that, I think. Yeah, so we need to do something like this. So this is going to be q0 dot y in this case. No, dot x in this case. Okay, sorry. And we want to check and see if this face is visible. This face is visible if x plus 1, not x minus 1, is visible. So if x plus 1, y q0 dot x. So if x equals 15 or... Okay, so this basically checks to see if the face is visible. Is the face visible? Bool face visible equals this. If this stuff is true, the face is visible. We add it to our height. Okay, so then we would say q0 dot height plus plus. Else break. Okay, so by the end of this loop, we have the proper height. Now we want to figure out how far we can push it in the width with this height. And I guess what we want to do too is check if the face is visible anyways, for like if this quad X, quad Y face is visible, because if it's not, we just want to skip it. So we'll do that too. Let's do that. Continue. And we'll say quad X plus plus, quad Y plus plus. Wait, do we want to do quad X, quad Y plus plus? We don't want to go, because that would diagonal. We want to do like quad X plus plus or something like that. Oh, okay. This is going to be tricky too. We'll wait on this, sorry. Okay. We're going to step through this code in just a minute to make sure that's all operating the way I think. Let's just get this part done first, and then we'll continue. So we do this. We have a height. Let's say for int z equals q0.z until z is less than 16, z plus plus, is the face visible? We need to make sure all the faces are visible in this particular stretch. I guess that's q0.x. So I think this is actually going to be a double loop because we need to make sure that they're all visible. Oh, I think I have this backwards. Okay, we want to do this first, then that. Control KD. So Z. And then we want to make sure, so then we say bool all visible equals false. Or actually, I guess we could say true. All visible equals false. And we don't want to do, whoops, that. We just want to say if not. And then if all visible q0.width plus plus else break. Okay, so this should get us our first quad. I think. Let's step through this and make sure it's working properly. Okay, so this is going to be X positive, the front face. Let's just, oh, I need a way to call this too. Let's step through it and make sure it's doing the right thing. First, let's go ahead and call this when we click export. So let's actually, we'll do that like that. And then inside of our main panel, if we click export new for our block editor, edit mode GUI, yes. If we export new, we're going to say player controller, export block type. Okay, and then we can import that or include it. Nope, not that. Core/player controller. Okay, cool. So let's do that. Now we should hit into that place we were working in. So let's put a breakpoint here. This doesn't matter. Let's put a breakpoint here. Okay. Let's see if this works. So, nope. What do we do? So I need to put this inside of here. No, I put that there. Export block type, export block type. Oh, it's because I have that static up here. Let's get rid of that. Okay. So we've got that. We want to look X positive real quick. So let's go. Let's turn that to none. X positive, I believe, is going blue forwards. So I think this would be X positive. Yeah, so I think this is what we want. And we want to look at the last slice. So let's do that. So what I think is going to happen and what should happen is basically we're going to go through here. So this is Q0. So it's going to go iterate Y first. So what it should do is we should get 15 for the height. Then we should get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 for the width. And we should get 0, 0. So this is the first quad is what it should be. So let's hit export and see what happens. Export. We get into here. So we're not going to hit this technically. Ah, crap. Yeah, this isn't good. Okay, we're just going to do this. So we're just going to look at this slice for now because I still don't know how I want to iterate as we go through. So let's try this again. So we'll do that. Place block, 16. There we go. Turn that to 1. Okay, we got that. Now, painter, paint. We should get, I should probably count that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. Okay, so 10, and we should get 15 here. So do that. So this should be a 10 by 15 square. Okay. So export new. There we go. So we get quad X, quad Y is 0. They're not 16. Oh, crap. Did I do that right? X is 15. Okay, yeah, that's fine. So that's 0, 0, which is what we're starting off with. And we start with 0, 0. Okay, so then Y is 0. X is 15. So the back index, or I guess this would be the front index, would be +1. So we should get this face visible true because this X is 15. So that should trigger that. So then what's going to happen is height ++. Yes. Is that correct? I think that's correct. And we should probably also be checking if the block is visible here. Yeah, okay, so we need to do one more thing here too. Sorry. SE Woods. I made a 3D engine in the past which have the same debug coordinate system as you, Gabe. Similarities in there though. Okay, so let's do cubes to 1D array x, y, q0.x dot is occupied. Okay, so that's the last condition we have to check. So make sure that the block exists and the face is visible. And then same thing here. Block exists and the face is not visible. Or if the block does not exist or the face is not visible. That's what we want to check here. D array. So if the block does not exist or the face is not visible. Okay. Try this again. We're going to get there, I promise. So, place block. 16. Delete that. That is painter mode. Paint. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Is that right? 12. No, we should get 11. Okay, so 11 width. And then 15 height or 16 height. Let's hit export. Okay, so go through this again. So height should go ++ because the face should be visible. We're on Y0. So right now we should be on that bottom left corner red is where we should be looking at if that face is visible. So height ++, height's 1. Okay, we should go through all of this. We should get height up to 16 or something like that. Or I guess 15. I don't know. We're at 7. We could just do this. 8. 13. 14. And then I think 15 is going to be the last one. Yeah. So we get up to 15. We should probably wait, height is 16. Oh, cool. That's perfect. Yeah. So height is 16. That's exactly what we wanted. Good. Now we should start iterating through the Z's, which in this case, we'll be going like left to right, pushing that whole slice left to right and making sure it can fit. So we should get up to 10 in this case. So all visible. We should get all of them visible for this one. Oh, crap. This should be Z. Whoops. Oh, that's annoying. Let's fix that real quick. Well, we know the first part works. So that's good. So Z. Z. Okay. Yes, let's do this again. I promise. We're getting closer. We are. So, place block. 16. That. Painter mode. Actually, first we want to delete one block here. Let's make it a little bit. We'll do like 3. That way we know exactly how wide it should be and we can iterate through pretty quickly. So paint that 1, 2, 3. That's how wide it should be. Okay, export. So if we get down to here, height is 16. Perfect. That's what we want. So now let's enter here. Z is 0. We are now iterating left to right. So we should be checking the whole slice now on that vertical. So the whole slice, we should get true here, right? So we should just loop through this whole thing. And then once we get down to here, all visible is true. Cool. So width goes up 1. Awesome. Go back here. We're on Z is 1. We should get all true again. So we should get through this. All visible true. Cool. We get 2. Let's go back up to here. Third one, we should get all true. Again, should work. We go here. All is true. Cool. So we get width is 3. Now, we should get we should hit an empty block, which means we can't push it further. So if we go through, we should get up to like, I forget, where exactly is that? Let's check it real quick. So that is like 1, 2, 3, 4, 5, 6, 7, 8, like 8 or 9 up, I think. So once we get to like y is 8 or 9, it should break. Y is 4, y is 5, y is 6, y is 7, y is 8, okay, y is 9, okay, y is 10, one of these should break, y is 11, okay, come on, oh no, y is 12, was I just counting wrong? Okay, I'm getting tense now, y is 13, is this going to work or not? Okay, nope, 14, nope, 15, no. Oh, wait, did it go? Wait, all visible was false. Should have been false. Was it? No, we got up to 14, 15. Oh, no. Okay, so that's not good. That did not work, right? Let's see if it gets it in this one. Maybe we're off by 1 somewhere. Let's see. X is 15. Y is 6. Z is 4. Have you ever had interest in robotics or any kind of hardware programming? Somewhat. I might look into that eventually. Real quickly, though, let's go to here. What do we get for our width? 12. What's 9 minus 3? 12. Wait, no. I mean 16 minus 3. 9 minus 3 is not 12. 16 minus 3 is 13. Wait, okay, so was it just doing it the opposite direction? I think this did work, guys. I think it did work. If we continue. Oh, it's going to get stuck in an infinite loop. Crap. Let's do this. Okay. So how are we going to check to make sure that this is working? We're going to do this incrementally. So we need to debug draw something. It's getting late. It's still pretty early for me. I've got plenty of time. Okay, let's do some debug drawing here, guys. And first we want to break out of this loop. So let's break out of this while loop after we do the first time. Yes, let's do a break here, and then we'll do a break here. So we'll just break out of these loops, and then we don't need to do any of this stuff. We can get rid of that. We don't need to do that too. Okay. What we can do is we can mark the blocks as we're going through. What about when hitting the export, color the quad faces in your editor to see it real time? Yep, exactly. That's what I'm going to do. So we'll say compile geometry after that, and we'll color these quad faces and make sure that's the right ones. So, okay, so once we get Q0 and Q1, what we can do is we can say for and Z equals Q. Oh, crap. Why am I doing 2 quads here? Oh, here. Sorry. Yeah. Let's do Q0. So we'll do this. For int Z equals Q0.x until Z is less than Q0.width, Z++. For int Y equals Q0.y until Y is less than Q0.height, Y++. And then what we'll do is we'll say cubes to 1D array, X, Y, Z, dot front face color, because that's the one we're focusing on, equals, we'll do like hex, FF, we'll do green, 00RGB, hex. Okay. And then we compile the geometry, so that should color the faces that it finds. So let's do this and see if we get the right thing. We probably should have done this first, but it's good to step through the algorithm and make sure it's working the way you think it is. Okay, so let's do that to 1. Do 1 there. And if I hit export, well, look at that, guys. Okay. Pog. I think that's a Pog moment. I think. So it found this as our Q0. Let's do Q1 now. So what it did was it's going right to left, which makes sense because this is positive going this way. And so what it did, let's get a better color here. What it did was it iterated this way instead, which makes sense. So yeah. So what we want to do now is Q1 should get this quad. So Q1 should be this stuff here. So let's see if we can get that. So if we do the same logic that we did here, except opposite, right? And then we're going to algorithmify this and make it all easier in a little bit. And how's it going, Voxerus? And render 1010, or I guess that is 10, binary 10. Yeah. How's it going, guys? Good to see you. So Q1, we're going to say is quad X, quad Y, right? Yep. And then we want to do the same thing we did here, except we're just going to do it like opposite. So we're going to do the loops in the opposite order. So we're going to do Z first. So that's that. So we do Z first, and then we do, this is going to be Q1 dot Y, and then this will be Z. So we're going to do this, and then we're going to do Q1.Y, and this is going to be Z. Okay, and then we're going to increment Q1's width. Okay, so that should be the width. Then we want to do the height. So then we want to push up, right? Same thing. Pog moment, Gabe and Bros. Yeah, I hope so. So now we're going to push up, which means we're going to iterate Y, then Z. So do Y equals Y till Y is less than 16, Y plus plus. And then we're going to check each Z. So we're going to do Z till it's less than 16. Yeah. Z, Z, and this is going to be X. This should probably be going until it's less than width too. Like Q0.X plus width. Yeah, so that's probably broken up here as well. This should be going Q0.Y plus height. Let's fix that. So that should be plus height. Q0.height. Yes, and then we should do the same thing here. Q0.X plus Q0.width. Okay, so that's what that should be. We'll make sure that works too in a minute. Okay, so then we do that. X plus 1, Y, Z. That looks right. Check if it's visible. Yep, all visible. If it's all visible, then we say Q1.height plus plus. Then we're going to draw that stuff. So do this. We will do blue. So this means we're going to overwrite some of the stuff, but we should at least get to see everything. So, and we want to do Q1. So Q1. Okay, so then if we do this, let's see if it works. Okay, so place block 16, got that. Let's go down to 1. If we take away that and we hit export, we get this. What's going on here? Access violation. So Y is 103. That's not good. 0 to height. Whoa, height is wrong. So second loop, what did we do wrong here? Something clearly went wrong here. Let's see. Q1.height plus plus. So this is width. Let's put a breakpoint here and make sure that width is correct. And then we'll kind of go from there. 16. Delete. Export. Width is 32,775. That's wrong. Why did we get that? Q0.X. So Z until Z is less than 16. Are we not increasing Z? Z plus plus. Yeah, that's fine. Forgot to initialize the width and height. Oh, thank you. That makes sense. Q1.width equals 0. Q1.height equals 0. Thank you. 0 initialization. It's important. You're getting random values. Yep, that makes sense. Thank you. Okay, so hopefully that means it's correct then, and we just had that wrong, which means we should be able to do this. Delete that. Okay, that's not right. We're close though, hopefully. Sam on work today. Yes. Let's see. What did we do wrong? Let's make sure that the top one is still working first of all. So let's just comment this out because it's possible that we messed it up when I changed that width to like X plus width or something. So 16, go down to 1, do that, export. Okay, so that's still working. That's good. So it is just that other piece that's broken. What did we do wrong here then? Let's uncomment that. So y equals q0y. Or I guess width. So width is fine. It's getting to 16, which is what it should be doing. And then what are we doing? We're saying, yeah, we want to push y up and then make sure that the whole slice is visible. Okay, so that's right. Oops, sorry. So we say z equals q0x until z is less than q0x plus width z plus plus. Is this right? We want to push y up. Wait, what are we doing up here? We're pushing z right. Yep, that's true. Okay, so we push z right. Push y up, yeah. I think what's going wrong is it's just not finding... This is not getting triggered for some reason. Let's iterate through it. Okay, let's just go through and see what happens. We'll put the block towards the bottom so that we should hit it like the first time. So let's do 16 there, and then let's do 1. We'll remove this block. Okay, so then if we hit export, we should hit it the first iteration. So all visible. We get z is 0. We're going up until z is 12, which makes sense because we can only go 12. Yeah, because of the way if we push it out that way. And y is 0, and we're going until y is less than 16. Push up. Yeah, I think that makes sense. So we're not going to hit it here. Or at least we shouldn't. We should get 16 for the height. Yeah, which we do. Okay, yeah, so that worked fine. This is exactly correct. We should be getting this. If we were going the other way, though. If we push out. If we push up... Okay, yeah, so in this case, both of the rectangles are going to be the same. Let's do this then. So if we do this, this should be... Yeah, okay, let's do that. So... Width is 12. Okay, wait, no. Width should be 16. That's weird. Oh, Q0. Duh. Q1. That's what I meant. Not Q0. Okay, let's loop through Q1. So we got same thing here. This should be Q1. So Q1, yeah, that's bad. Okay, so Q1, 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 Q1. Okay, cool. I think that was it. So let's try this again. Cool. So we should get red, blue, depending on the two quads. See if it works. 16, 1, delete, export. Would you look at that, guys? Red or green, blue. I was wrong. It got us the two quads. So technically this green goes all the way down here. And that's the only reason it should go all the way down here, but it got overwritten by the blue. But we did. We got those two. And then if I put it here, we get a little bit different. If we paint it, let's paint it real quick. White. And then we hit export new again. There we go. We get these two slices. Awesome. Okay. That's the first thing. Shemplo, Q0 is initial value of y in the second part. Yeah. I realized that just a little bit too late or too soon, I guess. I don't know. So we got that. Let's then do our comparison. See which quad is better, except that quad. So let's do the comparison check real quick. So let's go say int. Let's see. So we want to break up this slice into a certain amount of quads, which I guess we could just say container, right? Okay, yeah. So let's just say quad best slices or something like that. Wait a second. No. Okay, we're in here. Let's do this. We'll say quad. I don't know. I don't like this. So we've got Q0 and Q1. We're down to here. So let's choose which one is better. Let's use his algorithm that he did. So compare quads. Let's do this. Yeah, I'm copying, pasting. It's okay. We get what he's doing, kind of. It's all good. So let's go up here. Say static inline bool compare quads, which is something like that. And then we'll fix this horrible formatting. This is const quad ref q0 const quad ref q1 q0.y does not equal q1.y. And then if q0.x q1.y, I mean x, then we do this, q0.x q1.x. If q0.width q1.width q0.width q1.width, we're missing semicolons, and otherwise we return q0.height greater than or equal to q1.height. Okay, cool. Let's this is, I don't like this. I mean, I guess technically this is true, right? Where it's not really a nested if statement, or is it? Yeah, if return, if return, if return, return. Okay, yeah, so that's fine. Logically consistent, we're good here. So that compares the quads. What are we comparing though? Is this telling us Q0 is better than Q1? Okay, so this is telling us Q0 is worse than or equal to Q1. Okay, so that's what that tells us. So we want to take Q1 if this is true, Q0 if this is false. So if compare quads Q0, Q1, quad best quad. Actually, we could just do quad best quad equals compare quads Q0, Q1. If that's true, we want to take Q1. Otherwise, we take Q0. Cool. So now we can take the best quad, and then let's color the best quad yellow. That's what we want to do. Yellow is red and green, right? I think that's right. Okay, so then that should color the best quad red. Now, render 1010. So what's going on here? I see I am GUI. Is it also OpenGL? Yes. This is OpenGL. I'm building a block builder for my game. And basically, we're working on something called greedy meshing so that I can optimally mesh this thing into as few vertices as possible. So right now, what we're doing is we're trying to... This should return the best first mesh, and then we can separate this face into several quads and then hopefully get that working. So, okay, that's pink. Whatever, not yellow, pink. So this chose the best quad. It said the best quad was this one, which clearly looks right. This is 16 by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 16 by 10 as opposed to 16 by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, I think this was 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, yeah, so it chose the best one. But then if I were to do this, this should now be the best one. So if we do that again, if I paint it white first, let's do that. No, it's still saying that's better, but that's not. Let's see. 1, 2, 3, 4, 5, 6, 7 by 16. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is clearly the better one, so that should not be pink. So let's check our comparison thing again. So this says compare quads Q01. Best quad. Yep. Okay, so this is, let's examine what he's doing here. I mean, we basically just want to check and see which one has the bigger surface area, right? I think that's the goal. If that's not the goal, I don't know what it is. So let's just do that. Return. So yellow is red and green. You put down red and blue. Oh, okay. I just got that wrong. Thank you. So Q0.x, we want to get the surface area. Surface area is width times height. Q0.width times Q0.height. Q1.width times Q1.height. Yeah, I don't know why he had that as complicated as it was. We're just checking the surface area, unless he was doing something more fancy. I don't know. This is what we're going to do, because I think this makes sense to me. So do that. Now, if we do something like this, export pink. Okay, so this looks correct, right? We definitely have more surface area here than we do here. So it chose that one. But then if I go and make that like a 2 slice, then we should get, it looks like it did it right, but first let's paint it white. There we go. Okay, cool. So now it chose this one. Sweet. So now it can choose the best quad, and it does choose the best quad. And then where do we go after that? I guess what we do is we just like go, okay, so we've done this face. Then what we want to do is increment it in the height in this case. And we would start from here, repeat. And that's what we're going to do. One more thing that I'm going to check real quick is what happens if we do that. We should still get this one. Because now, sweet. Okay, and we still do get that one. And then let's do one more test. If we do that, and we do that, this is going to be the better one. Actually, let's do this. Let's do that. So we should get this strip. Oh, cool. And it corrected me. We should get this whole strip of cubes, which it did. It chose the best quad that we can get starting from here, which is this quad. Awesome. Okay, that's pretty good. So then I guess what we would do, we can't exactly, we just have to start iterating, and then we would go here and then do the same thing. And then we would go here, same thing, then here, same thing, here, same thing, which is probably not the most optimal, but I'm fine with this. This is kind of greedy meshing and it works. And then let's do ultimate test. If we were to do that and that, 16, that, whoops, not that, export, and it gets the whole face. Awesome. That is the most important thing. So it correctly identified that we can mesh the entire face there. Now this would be 1 quad instead of 16 quads. Awesome. Pog888, how's it going? And Essie Woods, will air blocks be squares, or will this editor be used to make different shapes with extrusions, intrusions, and stuff, not just color? Yes. So we'll be using this to like build actual extrusion, intrusion type thing, right? So I can like carve out a piece here, and then we can paint that, and that's exactly what happened. And then if we were to run this again with like that, you can see it would choose this face and then that and then that and that and sort of like mesh that. But yeah, this is working pretty good. I'm happy with this. Nice. Okay, I see everyone's pretty happy. So that's good because I'm happy too. I think I'm probably going to end stream right around here because it's been a long time. But we've got the basis for this greedy meshing algorithm. I guess we should have called this stream greedy meshing. Basically, what I need to do is I just need to repeat that for the rest of this and then push it back and then repeat it for all faces. That gets us our optimal mesh. And then I need to export that, import it. So, yeah, I think I'm going to end stream here. Thank you all for watching and coming here. And hopefully you can join me next week at around 8 o'clock CST. Central Standard Time, and we'll be doing like whatever's next on the list. So yeah, good to see you all. Thanks for watching, and I'll see you guys next time. Thanks.